Hello guys, and welcome to the GCE Math Panel Online. In this particular presentation, we have June 2021 paper 1 770. Please don't forget to subscribe to this channel, to share this video with friends, to leave your comments and likes, and to follow us on Facebook and on Twitter. Equally, you can have past papers and other materials for GCE on our blog www.gcemathpanel.blogspot.com or gcemathpanel.com. Please don't also forget to go to that blog and join our online preparation that runs every August to May in preparations for the GCE for the different subjects. Welcome once more. Let's begin with this paper. So the first thing I would like to reiterate here is that when you get your question paper, don't forget to fill in the correct information that is required. And as I've mentioned before, please get to our blog and join us for this serious full-time preparation online for the GCE. This is what we do every year, and don't be an exception. Share this information with all of your friends, that together we may put hands on deck and make our world a world of mathematics, the citadel of maths. We begin with question 1. The vector equation of a line passing through the points 1, 3, 4 and parallel to the vector I minus j plus 2k is... The vector equation is given by r equals a position vector plus a scalar times the direction vector, which can be written as this. Here we have the position vector, which is this 1, 3, 4, and it is parallel to this direction vector I minus j plus 2k. Even if they change this direction vector to or multiply it by negative 1, we will have minus I plus j minus 2k's. We will still have the same thing for this b here. So in this case, our result will be as follows, and we have the key to be C. The second question reads, a binary relation R is defined on the set of natural numbers by m relates to n implies m plus n is odd. R is... The relation is not reflexive since any odd natural number plus another odd natural number will give us an even number. Equally, if you take any two natural numbers, if they are both odd, the result will be even, and if they are both even, the result will be even. So it will only be odd if one is odd and the other is even. So this relation is not reflexive, because if we have, for example, 1 relates to itself will be 1 plus 1, which is equal to 2, and 2 is not an odd number. So the key here is the relation is only symmetric. And why is it symmetric? It is symmetric because addition is commutative. For example, 2 plus 3 is 5 and 5 plus 3 is 2. So it is symmetric. Question 3. Given that the roots of this equation are m and n, and also given that 3m is equal to 4n, find the value of the constant k. In this particular question, we are supposed to use the sum product property of quadratic equations. This means, in this case, we have x squared minus sum plus product equals 0. So minus sum, a minus sum will give us minus 14. So minus sum will be equal to minus 14. And since we have been told that 3m is equal to 4n, it means that m is equal to 4 on 3n. So our sum will now be 4 on 3n plus n, which is equal to 14. From here we can solve for n, and the value of n will be equal to 6. And our k, since it's the product, is mn. We have m to be equal to 8 by substitution, and our k, which is equal to mn, will give us 48. Our key here is D. Please, if you are watching this video, make sure you watch it till the end, because there are some new concepts that have been introduced this year which you should not let them pass by. These concepts are equally very important in paper 2 and paper 3, as you will see in the paper 2 and paper 3 that will be uploaded shortly. Question 4. The gradient of the tangent to the curve with parametric equations that and that, where t is a parameter at the point where t equals 1 is. So since we are looking for the gradient of the tangent and we have this equation in parametric form, candidates first of all need to look for dy dx and substitute t equals 1. So at dy dx here, or let's start with dy dt first, since it's in parametric form, is equal to 3. And at t equals 1, we will still have the value to be equal to 3. Equally, dy now, or the x dt rather, the x dt is equal to minus 2 on t squared. And at t equals 1, the value is equal to this minus 2 here. Therefore, our dy dx, which is dy dt times dt on the x, will be equal to minus 3 on 2. Normally, you can do the equation completely. You look for dy dx completely before you substitute this value, but you can still have the result like this. The result will be the same. Question 5. The range of values of x for which absolute value of x is really greater than 2 minus absolute value of x is. We have so many lessons on a block on this particular absolute value equations for advanced level. These are the first lessons of the first chapter. With an equation like this, you see that these are like terms. So we can bring these like terms together. And when we bring these like terms together, we will have absolute value of x times 2 is greater than 2. And when you divide both sides, we have absolute value of x to be greater than 2. And finally, using the rules, if you have issues on this lesson, go to the block. When we break this down, this is the results that we obtain. So our key here is A. Question 6. When a polynomial function f of x is divided by x minus 1, the quotient is 2x squared plus x minus 2, and the remainder is 3. The polynomial f of x equals. We have to use the relation of polynomials defined as dividend divided by divisor equals quotient plus remainder. And this will imply we have f of x, which is the dividend, this f of x, divided by this divisor, which is x minus 1, should be equal to this quotient. The quotient here is 2x squared plus x minus 2, and we have been told that the remainder is 3. But we have to be very careful in simplifying this operation. We have to do it as follows. F of x will now be equal to this quotient times this dividend, or this divisor rather, now plus the remainder. Look at where you're putting plus the remainder. So this is how it should be done. Be very careful not to make a mistake and do something else. When we expand and simplify, these are the results that we will obtain. And our key here is B. Question 7. The value of theta for which that expression is minimum is. Here, the function is minimum when the denominator is maximum. So when this denominator is maximum, this function will be minimum. And for this denominator to be maximum, there is a condition. For the denominator to be maximum, the sine of this angle must be equal to 90, because you know that sine 90 is equal to 1, and that's when you have the maximum value of sine. So it means therefore that this value inside this bracket should be equal to 90. So we say theta minus pi on 3 should be equal to 90, and then we solve for theta. At this point, our theta will be equal to pi on 2 minus, or rather plus, pi on 3, and this will give us 5 pi on 6. So theta should be equal to 5 pi on 6 for us to have the minimum value here. Our key here is A. The next question. The set of values of x for which this polynomial is greater than 0 is. We first of all start by looking for the boundary solutions. Boundary solutions occur when you equate each of these brackets to 0, we will have x equals 1, x equals 3, and x equals a half. We write it in ascending order like this. Then we can use the number line tool or a table of values to work it out. So here, these are the values. And we know that since this is an inequality, the values are a range. So we have this range for x less than a half, the range between minus a half and 1, between 1 and 3, and above 3. So you have to test. We take values and test in each of this range. For example, let's just take any number less than minus a half. We can take minus 1, right? When we take minus 1 and fit here, minus 1 is negative. That will give us negative. As you can see, this first bracket is negative. Minus 1 minus 3 also give us a negative number. And here 2 times minus 1 plus 1 is still negative. So it's negative times negative times negative. And what is the product? The product will be equal to negative. So you can already see that this region below minus a half does not satisfy, because the product of all of these should be greater than 0. And anything that is negative is not greater than 0. Now let us test in this region between minus a half and 1. We can easily use 0 because it will be easier and faster. So we fit zeros all through here. We have this one will be negative, this will be negative, and this one will be positive. So we'll have this result negative, negative, positive. And when we multiply all of that, we'll have a positive value. This one satisfies because it's greater than 0. The number must be greater than 0. And then we take a number between 1 and 3. We can take 2, for example. This will be positive, this will be negative, and this will be positive. So we will have positive, negative, positive, and the product is negative. So this region is negative. And above 3, all the values will be positive. Therefore means that our solution is this. From negative we have to 1 and above 3. So our key is D. Question 9. Given that y equals x to the power sine x, where x is greater than 0, find dy dx. With this type of questions, dear candidates, we start by taking ln on both sides first of all. So we take ln y should be equal to, when you simplify this ln on the right hand side, you have ln x to the power sine x, but you can bring it in front from the third law of logarithms or from further powers. You can bring this in front. Yes, so this will give us sine x ln x. We now differentiate both sides. When you differentiate ln y, you have 1 over y dy dx, right? And that should be equal to, for the right hand side now, we will have, when you differentiate ln x, you have 1 over x, you hold sine x constant. You now differentiate sine x, you have cos x, and you hold ln x constant. So this is what we have. We now solve for dy dx, or make it the subject of the formula, and our dy dx will be equal to sine x over x plus cos x ln x, all of that in brackets, times y. So this is the result that we have, and this gives us the key to be D. The key to be D. So we are talking a bit not much fast, because most candidates out there complain that our videos are fast, though you can equally control the speed from your device, but we are taking it at a moderate pace. Question 10. Let A be equal to that matrix and B be equal to that matrix. The order of the matrix products AB is, in this question you don't need to look for the matrix product AB. So the order of the products that we obtain AB is given by the order of, or let me say, the number of rows of matrix A by the number of columns of matrix B. So just by looking at these two matrices, the order of the product that we obtain is, we start with the A, right? It has 2 rows, and this one has 2 columns. So the order of the product that we obtain is a 2 by 2 matrix. So this is what we have. For A, we have 2 by 3, that's the order. And for B, the order is 3 by 2. So the order of the matrix of the products that we obtain, AB, will be this 2 by 2 matrix. And these numbers here tells us whether they're compatible or not. If the value that is here is not equal to the value that is here, then this matrix product is not possible. So they can ask what is the condition for this matrix product to be possible. We say that the number of columns for matrix A should be equal to the number of rows for matrix B. If they are not equal, it is incompatible. So our order here is 2 by 2. Our key is D. Question 11. The number of arrangements of the letters of the word manner in which A's are together is. In this case, we consider the two A's as 1, so we will have just 4 letters, of which 2 are identical, and this gives us, so since the A's must always be together, we can consider that the 2A is equal to 1A. So our word will now look like this: man, without the A at the end. So we consider this 1A here is equal to 2A's, but since they must always be together, they function just as one member. So this gives us 4 factorial over 2 factorial, and that is equal to 12. So we have 12 arrangements. The function f of x is defined as that with 2 intervals. Given that f of x equals f of x plus 4k, where k is an element of the set of integers, find f of 15. So to find f of 15, first of all, consider that the period of this function is 4. You can see from here from 0 to 2 and from 2 to 4. So the period is from 0 to 4. The period is 4. And since the 15 has been given here is positive, we can just divide this by the period. 15 divided by 4 gives us 3. We are interested in the remainder. So we have 15 divided by 4, and that gives us 3 remainder 3. We are interested in this 3. So this f of whatever you're looking for here is f of 3. And we see that this 3 lies in which interval? Is in the first interval or the second? 3 lies between 2 to 4. So we are going to use by this second part of this function to look for f of 3, because the 3 lies in this interval. And this will give us a value of 3 times 3, which is equal to 9. Note, if we were looking for f of something like negative 15, we will not use the same procedure. We will have to add multiples of this period of this function, that is 4, until the number becomes positive, like this. 15 plus 16 is plus 1, and we can now look for plus 1. And when we look for plus 1, this is what we will have. It will give us a value of 3. So be careful with this. Our key here is 9. It's D rather, which is having a value of 9. Question number 13. We have the statements P and Q. John is eating. Q, John is playing. The proposition negation of Q implies P is. So the negation Q of Q is John is not playing. Or here we can use if or whenever, since we have to merge or combine these two statements to form a compound statement. So this is how we do it. So for the negation of Q is John is not playing. So we say if John is not playing, this implication here is this then is replaced by then. We say then what happens? He is, this is P now, he is eating. If John is not playing, John is eating. There's no need to write John 2 times, as we know. So if John is not playing, then he is eating. 14. Values of y for which the values of x are shown in the table below. Using the trapezium rule, find the integral from 0 to 4 of y dx. For the trap rule, you need to understand that the number of strips is equal to the number of ordinates minus 1. Ordinates means how many x values. Ordinates we have 1, 2, 3, 4, 5. So we have 5 ordinates minus 1 will give us the number of strips or of stripes. So, and we know that our h for the trapezium rule is b minus a on n. This b and a is the lower bound, b is the upper bound, while n is number of ordinates minus 1. So this will give us n to be number of ordinates, but that is 5 minus 1. And we have our b minus a to be 4 minus 0. When we simplify, we have h to be equal to 1. Now applying the trapezium rule, we have that integral, and we fit in the values, which is h over 2 into first value of y plus last value of y plus 2 times the rest of 2 times the sum of the rest of the values of y. So this is giving us 1 over 2 into 4 plus 4 plus 2 times 6 plus 7 plus 5. This will give us 6 plus 7 is 13, plus 5 is 18. 18 times 2 is 36, plus 4, 40, plus 4, 44, divided by 2 is 22. So our key here is B. Question 15. The variables x and y are related by the law that. Reducing this law to linear form gives. So we just take log on both sides with this type of law. We take log on both sides. This one you see, I've seen mostly in sketching curves and various these relationships of equations or linear relationships. So when we take log on the left hand side, we have log y to be equal to. For the right hand side, when we take log, this is log of a product. So it's log a squared plus log b to the power x. And then we can simplify. So we now have 2 log a plus x log b. And this corresponds to which of these? This corresponds to A. So our key here is A. Then question number 16, the general solution of the differential equation, that is. We first of all start by separating the variables, and integrating gives. So we separate the variables. We have dy on y is equal to sine x over cos x dx. The sine x over cos x is tan x. So we introduce the integration on both sides, dx. So on the left hand side, the derivative of y on y is ln y. The integral of tan x is ln sec x, the absolute value of sec x plus k. So our key here is C. The sum Sn of the first n terms of a sequence is given by Sn equals n into 1 plus 2n, all of that times ln 2. The fifth term of this sequence is, so since they've given us the sequence in terms of sum, the fifth term should be equal to the sum of the first 5 terms minus the sum of the first 4 terms. So putting in these values to give us S5 to be equal to 5 into 1 plus 2 times 5 is 10. So 1 plus 10 ln 2, and simplifying gives us 55 ln 2. Equally, S4 will be equal to 4 into 1 plus 2 times 4, that is 8 ln 2, and this is equal to 36 ln 2. So our T5, that's the fifth term, T5 will be equal to S5 minus S4, and this will give us a value of 19 ln 2. B. Given that the equation 4x squared minus 3kx plus 1 equals 0 has equal roots and k is positive, the value of the constant k is equal to, or k is strictly greater than 0. The roots are equal if the discriminant equals 0. This is the condition now from quadratic theory. So we have discriminant which is equal to b squared minus 4ac should be equal to 0, and we get the discriminant here. This will give us minus 3 squared, minus 3k squared plus minus 4 times a, which is 4, times c, which is 1, that should be equal to 0. When we simplify this, we have 9k squared minus 16 to be equal to 0, and from here our k is equal to the positive square root of 16 on 9. Why? Because we have been told that k is strictly greater than 0, so you are not considering the negative roots of this. So our key here is B. (19) The equation of the circle with center at the point 1, 3 and passing through the point 2, 7 is. So if this equation passes through this point 2, 7, then normally, knowing that the equation of the circle is given by x minus a squared plus y minus b squared equals r squared, where r is the radius and ab are the coordinates of the center. So our AB here is 1 and 3, and our R will be 2 minus 1 squared plus 7 minus 3 squared, the square root of all of that. So our R is equal to root 17 and when we square this, we will have 17. So we have x minus 1 squared plus y minus 3 squared is equal to 17. We have removed all the roots. A key here is B. Question 20. To express this in partial fractions, we should look for the values of P and Q respectively. So in partial fractions, we have 2x minus 3 over x minus 3x minus 2 to be identical to that which has already been given. So from here, we multiply all through by the denominator, and we have 2x minus 3 to be equal to P into x minus 2 plus Q into x minus 3. Now, if x is equal to 2, we'll have 2 minus 3, which is minus 1, to be equal to this one will be 0. And we have 2 minus 3, which is equal to minus 1. So we'll have, okay, here we have 4 minus 3, which is 1, and here minus Q. So finally, our Q will be equal to minus 1. Now, when x is equal to 3, this term will cancel out, disappear. And we'll have 2 times 3, 6 minus 3, which is 3, and our P will be equal to 3. So P and Q are respectively 3 and minus 1. The range of values of x for which that expression is greater than 0 strictly is. So the boundary solutions here are, first of all, x equals 0 and x equals minus 3 from numerator and denominator. And we can solve by testing. So we have minus 3 and we have 0. So we test which points. Below 3, take any number below 3. And let's test. We start, we take any number like minus 4. Numerator will be negative, denominator will be negative. So this value will be positive. Now between minus 3 and 0, we can take 1 now. When we take 1, we will have, minus 1. Minus 1 plus 3 will be positive, and denominator will be negative. So this value in between will be negative. And above 0, you can take 1, for example, is going to be positive. So they want us to give the range of values for which this is going to be positive. So is that the range is below minus 3 and above 0. 22. The equation of a circle with endpoints 4, minus 2 and 3, 2 of its diameter is. So in the equation of this type of circle, we just have x minus x1. This is x1, y1, x2, y2. So the equation of that circle is x minus x1 times x minus x2 plus y minus y1 times y minus y2 should be equal to 0. So our key here is equal to A. 23, we have this integral from minus 1 to 2. The first thing to do this integral, you see that you consider the numerator is having the same degree as the denominator. So we first of all use long division and break it down as follows. X plus 3 on x plus 2 is equal to 1 when you divide using long division plus 1 over x plus 2. We can now apply the integration on both sides, and this is what we will have. When you integrate, you have x for this plus, when you differentiate this one, you have 1 plus ln x plus 2. I'm not adding the constants here because we have definite integration. We now apply the limits, and the limits are from minus 1 to 2. So this will give us, for 2, you have 2 plus ln 2 plus 2, ln 4 minus 1 now plus ln minus 1 plus 2, ln 1. Ln 1 is 0. So this will just give us 3 plus ln 4. Our key here is D. 24. The expansion of the function that is valid for. So this expansion is valid if this absolute value of this 3x is less than 1 and the absolute value of this x here is less than 1. So we have two values, but you see that for absolute value of x to be less than 1, we have from minus 1 to plus 1. When we take the intersection of the two, we have just this one like this. Just this minus 1/3 to plus 1/3. So we take this one because we need the intersection and not the union. It has to be valid for both, and this is the only intersection that occurs. Okay, question 25. The Cartesian equation of the curve whose parametric equations are x minus 1 equals sec theta and y plus 1 equals tan theta is. When we look at sec theta and tan theta, we can look for a relation that brings them together. We know that sec squared theta is equal to 1 plus tan squared theta, right? So let us use this identity of sec squared theta is equal to 1 plus tan squared theta. So sec squared theta will be x plus 1 squared. Then our tan squared theta will be equal to y plus 1 squared. So we have sec squared theta plus is equal to 1 plus tan squared theta. We can now bring these like terms together after simplifying. When we simplify, this is what you obtain, and finally we obtain b as the result. So the most important thing is to know what to do. I've just gone fast and forward with this one. So our key here is B, question 26. Please don't forget to subscribe to this channel, and you can go back to our blog www.gcemathspanel.blogspot.com. There you have the past papers for all the different years. You have information about concours. You have papers for all the other subjects. You have a lot of information that I cannot be disclosing here because there is just so much. Equally, it's very important that as you are preparing for GCE this year, go to our website gcemathspanel.com and join the online preparations. If you have A level or O level, technical or ATC, any of them, you choose your level and you join the other hundreds of students who are preparing for the GCE. Early preparation prevents poor performance. Don't forget. Alright, we take the next question, number 26. If the matrix that is not invertible or it is singular, and then the value of k is. A matrix is not invertible means its determinant is equal to 0, or the matrix has no inverse. Because invertible means has an inverse, not invertible means does not have an inverse. And this only happens when the determinant is equal to 0. So we will we look for the determinant here and equate to 0. You can use other methods with determinants. There are many ways to get the determinant of this matrix, right? And then we can solve for k from there. So from this point, our k will be equal to 3. Use any of the methods. You can even use a Saros method and all the other methods that you already know to get this the determinant. So our k here is equal to 3. Question 27. You have this integral. Here we need to use the substitution u equals x squared plus 3. You can see that when you differentiate this one, you have this 2x dx now. So let's use the substitution u is equal to 2x or x squared plus 3. So our du will be equal to 2x dx. And when we bring this inside here, we're going to replace this 2x and this dx by du. While we replace x squared plus 3 by u. And then to the power 3 on 2. So this will give us u to the power 3 on 2 du. And then we integrate. This will be equal to u to the power 5 on 2. All that over 5 on 2. And that would be the same as multiplying this thing by 2 on 5. Then plus the constant of integration. We can now replace the u by its value, which is x squared plus 3. And note that when we do this replacement, now this k will now change from this k to k prime. But in this question, we can just leave it like this. It does not matter. Let me say I root the k prime here and I've replaced it now with k. So our key here is going to be C. (28) A first approximation to the root of the equation e to the power x plus 2x minus 1 equals 0 is x equals 1. Using the Newton-Raphson method, a second approximation to the root of the equation is. Please don't forget to watch the paper 2 and paper 3 of this paper online, and don't forget to subscribe and share these videos and leave your comments. So the second approximation from this is the first root. It is always denoted x0. So we need a second approximation, and the second approximation is denoted x1, which is equal to x0 minus f of x0 on f prime of x0. So let's look for f of x0. x0 is 1 now, so f of 1 here will give us e plus 1. And our f prime, when you differentiate this, we have e to the power x plus 2, and e to the power f prime of 1 will be e, just e plus 2. When we replace these values here, we'll have 1, this 1, minus f of x0, all that over f prime of x0. So our key here is A. Question 29. The equation x cubed plus 3x minus 5 equals 0 has a root lying in the open interval. First of all, note that open intervals are written like this, or you can use these brackets in which the brackets are not facing each other. So f of x has a root in the interval AB if f of a times f of b is negative or is less than 0. So we are going to test each of these. We test the first one. We will have f of 2 times f of 3, and this will be equal to, we put these values here now, f of 2 is going to be positive, as you can see. F of 3 will also give us a positive number, so it's positive. Then f of 0 times f of 1 is positive 2. F of 1 times f of 2 will give us a positive number times a negative number, and f of minus 1 times f of 0 gives us a positive number. So the only one here that gives us negative is this third one, which therefore means that the curve crosses the x-axis only on this along this interval. So therefore means that the root lies in this interval. So our key here is C. 30. Given that the absolute value of z minus 3 equals 2 times the absolute value of z plus 3, where z equals that, the locus described by z is. The first thing I'd like us to notice here is that if you look at the coefficients of z here, it is 1, but the coefficient of z here is 2. With these absolute values, you just know that this describes a circle. If they were the same, it would be a line, because the x and y values may cancel out. This will surely give us a line. But now that the coefficients of this z are not the same, you hear the coefficient of z here is 1, because you can send these 2 inside. So this describes a circle. You don't need to solve for this one, but I'll still show you why it is a circle. So we replace this x, this z by x plus y iy, and simplify. This gives us the first one, x plus iy minus 3 equals 2 into x plus iy plus 3. And when you get these absolute values, this will give us x minus 3 squared plus y squared equals 2 into x plus 3 squared plus y squared. And when we simplify and bring like terms together, we will end up in an equation of this form. And you can start, this is the equation of a circle. So our key here is A. A to the x ln 5 is equal to, this can be simplified as e to the power x ln 5 is equal to e ln 5 to the power x. This is one of the laws of logarithms that you know. And we know that since the base here, this ln means the base is e, and you have e. When this base is raised to the log of that same base, the result is equal to just the function that is there. So our value here will be just 5 to the power x. These questions come every year now. GCE board. Asia. Then question 32, the approximate change in the value of ln x if x changes from 10 to 10.1 is. Here you just have to look for this change, and this change is estimated as ln 10.1 minus ln 10. Just punch in a calculator, it gives the answer directly, no stress. And this gives us this. Let us make the values to be as many as this, because we have 1, 2, 3, 4 decimal places, so we can take up to 5, so that if we approximate, we'll see what the answer gives us. So when you approximate this one, instead the only value we can have is this c value. So that gives us 0.0. This d value 0.01. 0.01. 33. The vectors that and that are perpendicular if the scalar q is equal to. So two vectors are perpendicular if their dot product is equal to 0. So we have to look for the dot products here. we will have 2 minus q minus 1 dot minus 3 minus 2 plus q should be equal to 0. This will give us 2 times minus 3, which is minus 6, minus q times minus 2, which is plus 2q, minus 1 times q, which is minus q, equals 0. And solving for q here, q gives us a value of 6. Our key here is C. 34. The vector perpendicular to the plane that is given by. Now, to get this vector that is perpendicular to this plane, it is given by the coefficients of x, y, and z. So the coefficients of x, y, you have 3 minus 5, 1. 3 minus 5, 1. So you can see that the key is already B, right? Let's recall that for us to have this, the vector equation of a plane, we have r dot the normal to the plane equals OA dot the normal. And this can be written as AX, since this r is x, y, z. So you have AX plus BY plus CZ equals D. This D is when you bring this A dot N to the left hand side, or when we leave it like this on the right hand side, and our D in this case here should be minus 7. Alright, so that is what we have. So the normal to this plane is this. From this equation you have 3i's minus 5j's plus k. You can see it directly. Alright, the last question for this first part before we move to the remaining 15 questions on statistics. We have A is equal to tan inverse of 5 plus tan inverse of minus 3. Then tan A is equal to, with this question we take tan on both sides. We take the tan on both sides and we lose the simplification for tan to simplify. So we have taken tan A on both sides, we have tan A to be equal to, these are two angles, right? This is like alpha plus beta. So it's equal to the tan of the right hand side. So when you have tan A plus B, how do you simplify it? You simplify it as tan A plus tan B, all that over 1 minus tan A tan B. So that's what we are going to do here. This will be equal to tan inverse of 5 plus tan inverse of minus 3. Then we are going to divide that value by 1 minus tan inverse of 5 times tan inverse of minus 3. Then we now simplify what we have. When we simplify what we have, we will have this tan inverse of 5 here will just be 5. Tan inverse of minus 3 will just be minus 3. All this over 1 minus 5 times minus 3. So this will give us 2 over 16, which is equal to 1 over 8. Yes, they gave this type of questions equally some years back. And they take most of these questions and repeat them and give the same thing. They just change the values. So you just have to be wise and solve some from recognition. Alright, you can equally look at other past questions and answers that we have like this, like 2019 and 2020 A-level. And you can equally get them from our website www.gcemathspanel.blogspot.com or gcemathspanel.com. Question number 36. Now statistics. The probability distribution of a discrete random variable x is given below. Find the expectation of 2x minus 3. So the expectation in general is given by, if you have something like 2x minus 3, the expectation is given by expectation of ax plus b is equal to expectation of x times a plus expectation of b, or a times expectation of x plus b. And using this one here, we just need to get the expectation of x, which is sum of xi times probability of xi. So we have 2 times 0.5 plus 3 times 0.3 plus 4 times 0.2, and this gives us a value of 2.7. So our expectation of 2x minus 3 will be equal to 2 times this 2.7 minus 3, and this will give us a value of 2.4. 37. The cumulative distribution function capital F of x of a discrete random variable x is given below. So with this, we have probability of x equals 1 is 2. Probability of x equals 2 is actually here 0.12. So they add them. The probability of this one to the probability of this give us 0.32. They add the probability of when x equals 3 to have this until the last value here should be 1. So how do we get the probability of x equals 4? Since this is a cumulative distribution, the probability of x equals 4 should be given by probability of x equals 4 should be equal to, since this is the sum from 1 to 4, 0.9, minus the sum from 0 to, or from 1 to 3. So is the accumulation from x equals 1 to x equals 4 minus the accumulation from x equals 1 to x equals 3. And this gives us 0.9 minus 0.67, which is equal to 0.23. I would like to thank all the candidates out there and the teachers who send us materials that we can upload for students to help them, especially those who are in the remote areas and those who don't have access to these materials. We pray that you continue to have the strength to carry out your work and to help our children in whatever they are studying. Thank you so much in your contribution for building the minds of our young children. All right, question 38. The probability of B prime intersection A equals 3 on 20 and the probability of A intersection B equals 1/4. Find probability of A. So I'll start by considering the vein shown. So this vein, that is B. I want to look for B prime. So this region in black is B prime. Now let's look for B prime intersection A. So I'm going to include A. So this region like this, that is in this funny blue, all of this blue region is B prime intersection A. So how do I get the probability of A? Now that I have probability of B prime intersection A, which is this blue region, I equally need the probability of this other small region like this. This other small region that we have this arc, that's the probability of A intersection B, so that I can have the complete probability of A. So this will be equal to probability of A equals probability of B prime intersection A plus probability of A intersection B. And this will be equal to 3 over 20 plus 1 over 4. And this gives us a value of 3 on 20 plus 1 on 4, which is equal to 8 on 20. 39. Alright, so our key here is 2 on 5. 39. Given that a random sample of 100 is taken from a population with a mean of 80 and standard deviation of 20, the distribution of this sample mean x bar is, this question is repeating, is one of the 2019 questions. So recall that the normal distribution is given by the mean and variance. So from here, our x follows a normal distribution with parameters 80, where 80 is what? Mean. And what's the next one? The variance is 400. So how do we get the standard deviation? We know that the standard deviation is equal to the square root of variance now. Alright, but now they've given us the standard deviation to be 20. So how do we get the variance from this? We square it. 20 times 20 is 400. So our normal distribution is 80, 400. Those are the parameters. Given that x follows this binomial distribution, the standard deviation of x is, this is what we have just discussed in the previous question. So the standard deviation is the square root of the variance, that is the square root of 16 in this case. And the square root of 16 is equal to 4. 41. A random variable x which follows an exponential distribution has a probability density function f of x defined by f of x equals 3 exponential minus 3x. What is the variance? For an exponential distribution, it is denoted by f of x equals lambda exponential minus lambda x. where the parameter is lambda. And for this distribution, the variance is given by the reciprocal of the square of the parameter. So 1 over lambda square is the variance. And from this equation, equating variables, you see that our lambda is equal to 3. So our variance here is equal to 1 over 3 squared, which is 1 over 9. 42. For a certain distribution, the equations of the regression lines of y on x and x on y are that and that, respectively. The product moment correlation coefficient for this distribution is. Here we must note that the line y on x has a gradient of 0.704, and let us call this gradient b1. So here our b1 will be equal to, for the line y on x, r times sy on sx. So this is what you have for equation 1, and you have seen these equations in product moment correlations. And then for the line, regression line x on y, let us use b2. So we are going to call this 1.140 as our b2, and this b2 will be equal to r. Note that this correlation does not change whether you use x on y or y on x. But in this case now, since this line is x on y, so we have the s on x on top as numerator on y, equation 2. So from here we are solving for r. So now making xy on sx the subject in equation 2 and substituting in equation 1, it gives us, we will have in equation 1 have our b1 to be equal to r dot. When we make this sy on x here the subject of the formula, we'll have sy on x to be equal to r on b2. So we substitute here, we have equation 3, and we can put in our values and simplify. So r squared, here r squared to be equal to b1 times b2. Normally I could just do this thing directly, but I want you to know that whenever you have something like this, know that your r squared is equal to this b1 and b2, this gradient times this gradient, and then or the square root of the product of those gradients, and this gives us a value of 0.896. 43. Given that x follows a binomial distribution m 0.8 with expectation equals 16, the value of m is, for a binomial it has two parameters n and p, and the expectation is given by np. So here we have our 16 to be equal to np, which is m times 0.8, and m is equal to 16 divided by 0.8, which is equal to 20. So our key here is B. 44. A random variable x is such that it follows a Poisson distributor with parameter 7. What are the modes of x? Whenever a random variable x follows a Poisson with parameter lambda, then there are two things that are involved. One, the modes are lambda and lambda minus 1 if lambda is a positive integer. In this case, we have a positive integer, so we are going to have two modes. However, if it is not a positive integer as we have, the mode is the largest integer, less than or equal to lambda, if lambda is a known integer. That is, if lambda is not an integer, then we take the nearest integer, which is less than or equal to lambda. So in this case, our modes are 7 and 7 minus 1, that is 6 and 7. So we have C. 45. The mean of a set of 5 values is m, and the mean of the second set of 8 values is 16. Given that the mean of the combined set is 13, of 13 values is 17, what is the value of m? We use the mean of the combined to look for m. So the sum of all the 13 values should be equal to, because we, in this particular case, for the set of 5 values, we divide by 5, that is the sum by 5 to have m. So to have that sum, you say 5 times m. Then for this one, we divided by 8 to have the mean to be 16. So to have the sum of all the 8 values, we say 8 times 16. We sum these two. Now, the mean for all the 13 numbers, they have been told that is 17. So all of this divided by 13 should be equal to 17, and when we solve for m from here, we will have our m to be equal to 18.6. So the mean is 18.6 for those five first values. For the mechanics students, please you can tell them to watch the video titled 765, where they'll have their own corrections. But note that these first 535 questions here are the same for the mechanics students as well. This question says the hypothesis test is designed to test. This is a question that repeats from 2019 also, and they have just changed some values and some few things, but it's the same question. They have altered some values of the result of these values here, alternatives, but the answer is the same. Nothing has changed. So you can go through 2019 and you see this same question. Alright, so for this question, a hypothesis test is designed to test a combined population mean of 420. A random sample of size 100 drawn from the population had a mean of 423. If the population variance is 144, then the statistic for the test is, so the test value is given by z equals x minus mu on sigma on root n. So this gives us 423 minus 420 on 12 divided by root 100. This gives us 2.50, the same answer for 2019. So this is the test statistic or test value. The table below shows rankings of 4 contestants by 2 judges X, Y, and Z. Find the Kendall's coefficient of rank correlation for the above data. Note first of all that Kendall's is different from Spearman. They have been given Spearman all over the years, but this particular year they have given us Kendall's. So for Kendall's, we first of all make a table like this. You can see now we copy out these values like this. I want to display like this, that is easier for me to explain better. And you must make sure that for this first on this table, these numbers are in increasing order. As you can see, in increasing order. If the numbers were not in increasing order, then I will make them to be in increasing order. But note that whenever I change any value, I must take the corresponding entry of ry. For rx, I must change one of ry. So for the first one, it should be in increasing order. In our case, it's already increasing order, so don't change anything. Then we write out our ry like this. And then these c's are for the values of conformance. So here, now we make Rx in increasing order. If it's not increasing order, once you order it, then note that Ry also vary. The second thing to do is to compute the C values. And the C value is a count of the number of ranks in Ry which are higher than the rank in the considered row. So if I consider this row, look at this row. This is where Ry is. I count all the values along this column that are higher than this one. So the first value here along this row, how many values are below this row that are higher than 1? We have 1, 2, 3. So I'm going to write 3. This is the next row. Looking at this row, how many Ry values are higher than 2? We have 3 and 4, so that 2. And then if the next row, which is 3, how many Ry values are higher than 3? It's just one value, which is 4. And then for this row, there is no other value again that is there that is higher, so I'll just put a 0 there. And then the next thing now is to compute the values of D. To compute the value of D, we do the same as we are doing in C, but we now consider by the values that are lower. The same for the same Ry. So I'll come now to D. This first one is 1. How many values are lower than 1 along this column? There is no value. Along this column, how many Ry values are lower than 2? There is none. Along this column, how many Ry values are lower than 3? There is none. And along here, there is none. The next thing to do now is to sum them. You sum the C's and the D's. So for this column, you have the sum is 6, the sum here is 0. And then now our R Kendall is equal to C plus D minus over C minus D. So we have 6 plus 0 over 6 minus 0, and that gives us 1. We have discussed more about this in our blog on GCE Math Panel Online classes. The blog GCE Math Panel Online classes. or you can go to gcemathspanel.blogspot.com, and from there it will take you directly to the blog. So our key here is C. Question 48. A population has mean mu and standard deviation of 4. A random sample of 64 taken from this population has mean 24. A 98% confidence interval for mu using the sample is. So for the 98% confidence interval, our Z value is 2.326. I know you know they think the values of 95, 97, 98, 99 confidence intervals by heart. You don't even need to use a formula booklet for this because you have been working with this in class all through, and even the 90%. So the population mean will be given by mu equals the sample mean plus or minus the Z value times sigma on root n. So we put in the values, and this is what we will obtain. We have a sample of 64, we have a standard deviation of 4, and our alpha value is 2.326 at the 98%, and our population mean is 24. So when we simplify, we have 22.837, 25.163. Our key here is A. (49) A continuous random variable x has probability density function defined by that. The value of the constant k is. So we know that the probability density function, the integral of that function from negative infinity to positive infinity is equal to 1. But this function is only defined from 1 to k. So we integrate it from 1 to k and equate to 1. When we integrate, we have x minus x squared on 8 from 1 to k is equal to 1. And when we solve for k, we end up with a quadratic equation, and that quadratic has two roots. We have k equals 5 and k equals 3, but they have given us just one of the values here. Here we'll just consider the one that is there. K equals 3 from 1 to 3. If you're not clear with any concepts, you can watch this video over and over again. Don't forget to subscribe, leave your comments, like the video, and share. And the last question, but not the least, to estimate the variance of a population, two independent samples are drawn to produce the following results. So we have for sample 1, we have 40 items with the variance of that. Sample 2, 50 items, the variance of that. What is the unbiased estimate of the population variance? So for all the sum of all the 90 scores we have, for this one, to have the sum of all of these scores squared, we have 40 times this, because it's divided by 40 to have this value. So now plus this one times 52, and we divide all of this by 40 plus 50, 90 now, because it's unbiased, and this gives us 1.488, which you can round up to 1.49 to 1 decimal place, to 2 decimal places, sorry. Thank you guys for staying tuned, and the next paper is paper 2. Don't forget to watch paper 2. Paper 2 will be uploaded. It's already uploaded. Look at paper 2 and as well as paper 3. Leave your comments on the links below and follow us on Facebook. We have live classes on Facebook every Sundays from September to May, every Sundays. And equally, we have classes, intensive preparatory classes in our blog, where we have tutorials and what we call super quizzes at the end of each month. And all students working with us are compelled to work with this. Thank you so much and stay tuned. Don't forget to watch the other papers, and we are together. Goodbye.
Hello, dear candidates. Welcome to the GCE Maths panel.
And in this particular presentation, we are looking at June 2021 A-Level Maths Paper 2. June 2021 A-Level Maths Paper 2, 770 and 765. So it will be very important that you watch this paper to the end and you don't forget to subscribe. You can visit www.gcemathpanel.blogspot.com where you can get all our past papers and correction. www.gcemathpanel.blogspot.com where you can get all our past papers. And please do not forget to subscribe, because when we upload new videos, you'll be immediately notified. So let us begin this paper of June 2021, paper 2, 770 and 765. Don't forget to share this video with your friends and to leave your comments. Without subscribing, you cannot watch paper 3. So the first question reads, a polynomial function f of x is defined by f of x equals 3 minus ax plus bx squared minus x cubed. When f of x is divided by x plus 2, the remainder is 45. Given that 3 minus x is a factor of f of x, find the values of the real constants a and b. So with this question, we have to apply the knowledge of the factor and remainder theorems. And we know that x plus 2 is not a factor. That is why the remainder is 45. On the other hand, 3 minus x is a factor, which means the remainder is 0. So we can form two equations with two unknowns a and b, and we solve that simultaneous equation. Let us answer the first part of question 1, and then we move to the partial fractions. So we have been told this equation on the bottom right. So when we divide this by x plus 2, the remainder is 45, right? So we equate x plus 2 to 0. That will give us x to be equal to -2. And since x plus 2 is a remainder of 45, it means f of -2 will be equal to 45. This therefore implies that 3 minus a times -2 plus b times -2 squared minus -2 to the power 3 should be equal to what? 45. This should be equal to 45. So we can simplify. We'll have 3 plus 2 a's plus 4 b's plus 8 is equal to 45. This gives us the first equation. A plus 2b is equal to 17 when we simplify. Now the second condition is 3 minus x is equal to 0, and which is a factor. So we have 3 minus x equals 0, implying that x is equal to 3. And since this is a factor, it means that f of 3 will be equal to 0 because this is a factor. So this will give us the same thing. We have 3 minus a into 3 plus b into 3 squared minus 3 to the power 3 is equal to 0. When we simplify the second one, we have 3 minus 3a's plus 9b's minus 27 to be equal to 0. And this gives us equation 2, which is minus a plus 3b equals 8. So we can solve these two equations directly by elimination. We add equation 1 to equation 2. This will give us 5b's to be equal to 25, implying b is equal to 5. We now substitute the value of b in one of the equations, equation 1, b. So from equation 1, a will be equal to 17 minus 2b's. That is 17 minus 2 times 5. That is 17 minus 10, which is 7. Okay, so this is it for the first part of this question. And the second part is we should express 5x over x plus 3 into x minus 2 in partial fractions. Guys, please don't forget to subscribe to this channel. And if you need past papers, go to www.gcemathpanel.blogspot.com and equally subscribe so that whenever we have any new post, traveling abroad for studies, different concours in the country, have to prepare for exams, and different subjects, you can always get the notifications. And this can only happen if you subscribe. Without subscribing, you can't watch paper 3. So let's express this in partial fractions. We know that is the simple case. So this will be identical to, with this denominator, we have linear factors, right? So we just have a constant over the first linear factor plus another constant over the second linear factor. Now we multiply all through by this denominator of the left-hand side. We'll be left on the left-hand side with 5x is equal to a over x plus 3 times this LCM. Will be left a into x minus 2. When we multiply b as well, we'll be left with b into x plus 3. So we can use the cover-up method, right? So what will happen if x is equal to 2? So we are taking this first factor here and equating to 0. X minus 2 equals 0, so x is equal to 2. So if x equals 2, we substitute in this equation that we have, this 5x equals that. We will have 5 times 2, which is 10, is equal to a into 2 minus 2. This part will become 0, so we have covered up this part, plus b into x plus 2, but that x is 2. So we have 2 plus 3, which is 5 times b, 5 b's. That gives us 10 is equal to 5 b's, and b equals 2. Now we use the other factor x plus 3, equates to 0, and solve for x. We'll have x equals minus 3. So what will happen when x is equal to minus 3? When x equals minus 3 and we substitute in this equation, we'll have minus 3 times 5 is minus 15 is equal to minus 3 minus 2 is minus 5 times a minus 5a's. And this other part, we have covered up this part because it disappears. This is some sort of elimination, which they call cover up. So that now that we have our values of a and b, our f of x becomes 3 over x plus 3 plus 2 over x minus 2. So we have expressed this in partial fractions. We have expressed it in partial fractions. And all of this question is 8 marks. That is 5 plus 3, 8 marks. Don't forget to subscribe. Now the second question reads for June, and if you look at June 2021 very well, it is almost exactly the same as June 2019. The questions have slightly changed. So this is exactly June 2019, which has been moderated or modified and put here. You can visit our channel on YouTube, GCE Math Panel on YouTube. You will see 2019, the questions and the answers. You see 2020, the questions and the answers. And now 2021, you equally see other years, they're like 2016, 2013. And if there are other years you want us to solve, then you should get to us on the links. Leave a comment here that you would like to see this particular year or this year. And then we are going to upload it. Some of these corrections are not on YouTube. So it is good you visit our blog, www.gcemathpanel.blogspot.com, where you can find the corrections we have hidden there. So this is question 2. It reads, given that the roots of the quadratic equation, x squared plus 2k plus 2 into x plus 2k plus 5 equals 0 are alpha and beta. A, find the values of the constant k for which alpha equals beta. So the roots are alpha and beta. And the first case, we want us to find the values of the constant k for which alpha is equal to beta. And B, if k is greater than 0, normally it means that from the A part, we may have the values of k which are positive and k which are negative. So in this B part, we are going to use the value of k that is positive. So B reads, for k greater than 0, that is strictly greater than, find the quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. And the second part of the equation is to find the range of this inequality. Let's start with the first part. So we have been told that the roots of this quadratic are alpha and beta. We should find the values of the constant k for which alpha equals beta. So normally the general form of the quadratic is x squared minus sum of x plus sum of root plus product. So this quadratic here should be identical to x squared minus sum of root, which is alpha plus beta, plus product, which is alpha beta. And from this point, our alpha plus beta, that sum of root, should be equal to minus 2k plus 2. Can you see? So we equate the coefficients of x on both sides. You see that alpha plus beta is equal to minus into 2k plus 2, right? Then this 2k plus 5, which is a constant on the left-hand side, the corresponding constant on the right-hand side is alpha beta. So our alpha beta is 2k plus 5. 2k plus 5. Okay, now if alpha is equal to beta, what happens? If alpha is equal to beta, then for the first equation, we will have 2 alpha because alpha is equal to beta. So we'll have alpha plus alpha, which is 2 alpha will be equal to minus into 2k plus 2. And for this second equation, what are we going to have? You will have alpha, so we can replace this value of alpha in this second equation here, right? Since our alpha, because when we simplify this one, we'll have alpha is equal to minus into k plus 1 because 2 is common. So if you substitute this value of alpha in this second equation, that is alpha beta is equal to 2k plus 5, then we will have alpha is minus into k plus 1, right? So we have minus into k plus 1 times minus into k plus 1 should be equal to 2k plus 5. So alpha is equal to beta here. We have minus into k plus 1 times minus into k plus 1 is equal to 2k plus 5. When we expand, we'll have k squared plus 2k plus 1 on the left-hand side should be equal to 2k plus 5 on the right-hand side. When we bring like terms together, these two k's are common, right? So we'll have k squared to be equal to 4, and our k will be equal to plus 2 or minus 2. So those are the two values of k for which alpha is equal to beta. K equals 2 or k equals minus 2. Now they want us to find the quadratic equation with whose coefficients or roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. And here they want us to use the value of Ka that is positive in this same equation above. So let us move with this. So for K greater than 0, it means that the value of K is 2, right? So we are going to substitute K equals 2 in this given equation. And this will give us x squared plus 6x plus 9 equals 0. So from here now, we have alpha plus beta in this equation is minus 6 because this is x squared minus sum of roots plus products. So alpha plus beta is minus 6 and our alpha beta is equal to 9. Now let us look for the new sum because they want us to use 2 alpha plus alpha beta and 2 beta plus alpha beta. So what's our new sum? Our new sum will be equal to 2 alpha plus alpha beta plus 2 beta plus alpha beta. And this will give us 2 into alpha plus beta. That's 2 alpha plus 2 beta, 2 into alpha plus beta, plus 2 alpha beta. But we know that alpha plus beta is minus 6 and alpha beta is 9. So this will give us 2 into minus 6 plus 2 into 9. When we simplify this, we are going to have minus 6 as our new sum. So our new sum is minus 6. Now our new product will be 2 alpha plus alpha beta times 2 beta plus alpha beta. When you open, you have 4 alpha beta. That's 2 alpha times 2 beta will give us 4 alpha beta plus 2 alpha times alpha beta will give us plus 2 alpha squared beta. Now alpha beta times 2 beta will give us plus 2 alpha beta squared, and alpha beta times alpha beta will give us alpha beta all squared. So with this one at the center, we can bring like terms together and do some modification. So for 4 alpha beta plus 2 alpha beta into here, we'll have alpha, and with this one we'll have beta. And then we continue with our alpha beta all squared. Now we know the values of alpha beta and alpha plus beta, so we just substitute those values here and simplify. All right, so this is what we have, dear candidates. This is what we have. So therefore means that our new product is equal to 9. When you simplify all of this, you'll have 9. And therefore our new equation will be given by x squared minus sum of roots plus product, which is going to be equal to x squared minus sum of roots, that is minus 6x plus 9 equals 0. A lot of students had a problem with this question at the GCE when they were marking. So it is possible that this type of question may come again next year. Or if it does not come next year, they'll give it the year after next. Like the questions of 2019 had a lot of problems. They have given most of them again this year. The GCE does not really change. You just have to answer as many past questions as you can and also study in class. You cannot answer those past questions without content mastery. Okay? And solve as much as possible. Even as you watch this video and you don't understand something, rewind it and watch again. And as you watch, solve. Make sure that you solve everything that has been solved here. You can use other methods. It must not be exactly the same method here. Hope you understand this. Very important. Now, to find the range of values for which this makes sense, there are two methods. We are going to use the two. So we can use the method of, how can we put it? So we have this. So for this particular inequality, we know that the denominator should not be equal to 0. If it's equal to 0, this will be undefined. In this case, therefore means that our x cannot be equal to -1. Because if x equals to -1, this inequality will be infinity, which will make it undefined. But x can be equal to 2. If x equals to 2, this value will be equal to 0. This thing will be defined. So the boundary solutions are, we have -1, which is not inclusive, so we are not going to shade it. And we have 2, which is inclusive, which is included. So here, this is a number line. -1, it cannot be equal to -1, so we have not shaded it. But you can have 2. This is equal to 2, this inequality will be defined. So this here, we are going to use less than or equal to if it exists. And here, we should not use the equal to sign, whether with less than or with greater than. So these are the different regions that we have. These are the boundary solutions. So we can test each of the regions. Not that inequalities, we are looking at a range of values, not a particular value. That's why we're using this. So we can test, let's start with the region below -1. The region below -1, take any number less than -1. For example, -2 and test. So 2 minus -2, the numerator is positive. The denominator, -2 plus 1 is negative. So the numerator is positive, the denominator is negative. Positive divided by negative is negative. Now question, is a negative number greater than 0? No. It means that this region below is the wrong region. Now let's test this region in between -1 and 2. Take any number between -1 and 2, for example, 0, and test here. We have 2 minus 0 is 0. So numerator is positive, but denominator 0 plus 1 is 1. Denominator is also positive. Positive divided by positive is positive. Is a positive number greater than or equal to 0? Yes. This means this middle region is the correct or the satisfying region. Take any number above 2 and also test. For example, 3. 2 minus 3 is negative with the numerator, and 3 plus 1 is 4, positive with the denominator. Negative divided by positive is negative. Is a negative number greater than or equal to 0? No. It means that the region above 2 is the wrong region. Therefore, our solution set is x is strictly greater than -1 and less than or equal to 2. Or you can write it in interval notation as from -1 to 2. Can you see? -1 is not included. That's why this thing is like this. Or you can use a normal bracket here. But for this one to the right, after 2 is included, so you cannot use that bracket. Use this square bracket. Okay? So you can write in interval notation like this or with this other form. Now, let's look at the other approach. We can use the table as well, right? So by table, we can use the table approach. So by table is just the same thing, okay? You can use any of them. So by table, from these boundary solutions, we have this x. We have the region x is less than -1. We have the region x is less than, is greater than -1 and less than or equal to 2. And you have the region x is strictly greater than 2. Now, these are functions. The numerator is 2 minus x, and the denominator is x plus 1. So this divided by this, or this times this, whatever, is going to give us the function below here, f of x. F of x is equal to numerator divided by denominator, right? Now let's test the region. So it's the same thing. Any number less than -1, for example, -2. Fit -2 here, 2 minus -2. The sign is going to be positive here. This sign is positive. Then minus 2. You feed minus 2 here. This one is going to be negative. And what is positive divided by negative is negative, right? So f of s is negative. Now let's take any number between minus 1 and 2. 0, for example. 0, for example, and fit here. 2 minus 0 is 2, which is positive. 0 plus 1 is 1, which is positive. And positive divided by positive is positive. Now take a number greater than 2, for example, 3. 2 minus 3 is negative. 3 plus 1 is positive, and negative divided by positive is negative. Now we are looking for the region that is greater than or equal to 0. The question says greater than or equal to 0. So we are looking for the region that is positive because they say greater than or equal to 0. If they said less than or equal to 0, we will take the negative one, right? So this one is the one that satisfies that inequality. So our solution set is x is strictly greater than -1 and less than or equal to 2. So this is it for question 2. And make sure, if you are watching this question, make sure you watch this paper to the end. There is no need to watch this paper, just half of this paper. You can equally get a lot of materials by going to www.gcemathspanel.blogspot.com, and you can visit that page every day for updates. Some of you like specos. We don't believe in speco, but we have specos on that page. And all our specos, you can see the testimonies on that page for yourself. Question 3, show that 3a minus sine a of cos 3a plus cos a is equal to tan 2a. Guys, with this question, please do not try to expand this thing and simplify. You will suffer and you might never get to tan 2a. Yes, it will become very difficult for you and you might not find yourself at tan 2a. Let us look at the first part of this question, then we move to the second part of it. So with this question, this is what we are going to have. So we know that we have to work with the left-hand side and show that the left-hand side is equal to the right-hand side. So we have sine 3a minus sine a over cos 3a plus cos a. This will be equal to, now this is the hint. We will have to move from sum to product property for numerator and for denominator. We know that sine a minus sine b is equal to 2 cos a plus b on 2 sine a minus b on 2. This is the transformation from sum, from difference to product. This is the transformation. So here, according to this question, our a here is 3a and our b is a. So this will be written as, and for the denominator, cos a plus b or cos c plus d is the same as 2 cos c plus d on 2 cos c minus d on 2. You know these transformations. If you use this transformation, you get to your answer in a few steps. If you try to expand, it will take a very long time and you'll just be suffering yourself for nothing. So the shortcut and the fastest way here is to use this transformation, okay? So the numerator is going to give us 2 cos 3a plus a on 2 sine 3a minus a on 2 over the denominator we'll have 2 cos 3a plus a on 2 cos 3a minus a on 2. So this will be equal to 2 cos 2a sine a on 2 cos 2a cos a. Okay? But now this cos 2a cos a will cancel out with the 2 and we'll be left with sine a on cos a. And you actually even see that with this question, this is equal to tan a and not tan 2a. So you have to emphasize in your response that this is not equal to that. When they start to show that something is equal to this, doesn't mean that it must necessarily be equal to that thing. Well, we think that this must have been a typing error. So when you solve, don't worry. The markers know exactly how they're going to take care of this problem, okay? Yeah, they know exactly how they're going to take care of this issue. So you don't have to bother yourself about anything. You don't have to worry yourself. So it does not mean that all the time they start showing that this is equal to this, means that it's equal to that. You have to prove at times and you start, it is not equal to. The B part of the equation states that given that f of theta is equal to sine theta minus root 3 cos theta, express f of theta in the form r sine theta minus lambda, where r is a positive constant and lambda is an acute angle. So we know that r sine theta minus lambda, when you expand, we are going to have r into sine theta cos lambda minus sine lambda cos theta, right? And this is identical to what we have in the equation. In the equation, we have sine theta minus root 3 cos theta. So sine theta minus root 3 cos theta. So from here, we see that if you equate the corresponding components, what do you see? You see that r cos lambda is equal to 1. R cos lambda is equal to 1. And look at this other part. This minus, this is a minus here. So we have r sine. This is it. Cos theta, we cancel with cos theta, right? So we have minus r sine lambda is equal to root 3. Okay. Minus r sine lambda is equal to minus root 3. So the minuses will cancel out. And we are left with r sine lambda is equal to root 3. So from here, we can look for r, right? We know that r, if you square both sides and add them, so we have the left-hand side, r cos lambda squared plus r sine lambda squared should be equal to 1 squared plus root 3 squared. And the left-hand side, when you square the left-hand side, you have r squared into sine squared lambda plus cos squared lambda is equal to, on the right-hand side, 4. Note that root 3 squared is 3 plus 1, 4. But sine squared lambda plus cos squared lambda is 1. Therefore, r squared is equal to 4. And r is equal to 2 because the equation says that r is a positive constant. We can now look for the acute angle lambda. So r sine lambda divided by r cos lambda, we can divide. We will have tan lambda to be equal to root 3. And from here, lambda will be equal to arc tan root 3. And arc tan root 3 is pi on 3. If you use a calculator with a cos, with a angle in degrees, you have 60 degrees. You can convert to radians, okay? So you have pi on 3, that's the value of lambda, right? Now they want us to find, so this f of theta can be expressed as r sine, according to the equation, theta minus pi on 3. They want us to find the general solution of the equation sine theta minus root 3 cos theta equals root 2. Since they have said hence means we must continue with this last answer we have. We have no other choice. We must continue with this answer. You have no choice. There's no other method you use. That's the hence. If you use another method, that's advanced level. Don't follow instructions, you are in the pit. So we continue with this. We know that this sine theta minus root 3 cos theta is equal to what we have here, which is 2 sine theta minus pi on 3. And so we can replace it by that value. So sine theta minus pi on 3, please, this is theta, not 3. Okay, let me just adjust it. Okay. All right, theta. So minus that, so we have sine theta minus pi on 3 is equal to root 2 on 2. And root 2 on 2 is sine pi on 4, sine pi on 4, right? 45 degrees. So how do you solve the equation sine A equals sine B? For sine A equals sine B, we will have the general solution. Theta minus pi on 3 is equal to n pi plus minus 1 to the power n times pi on 4. And our theta now will be equal to n pi plus minus 1 to the power n pi on 4 plus pi on 3, where n is an element of the set of integers z. So this is our general solution for this given question, okay? So take a good look at it. And as I've said at the end of this question, or as you are watching, be solving. Don't just watch this paper. This is not a movie. This is not an Indian movie or a Hollywood movie. You don't have to kill yourself. It's not Bollywood, Nollywood, or Hollywood. Maybe it's even Kamwood. Don't waste yourself and disturb yourself here. There's no Kamwood. Okay. So this is the shortcut for sine A equals sine B. This is what you use to solve when you have sine A equals sine B. Question 4. The real value function f is defined by, so this function is a real value function. So it's defined by, we have 4x on x minus 1, where x is an element of the set of real numbers. And x should not be equal to 1 because the function will be undefined, right? Show that f is injective Then find f of x, stating its domain. This is exactly 2019 question that I've just modified a bit. The same thing. Let's answer the A part and then we move to the first part and then move to the second part, okay? So a function is injective if what happens? Function is injective if f of x is equal to f of y implies x is equal to y. So f is injective if f of x equals f of y implies x equals y. For every x and y, an element of the set of real numbers. So f of x here, f of equals f of y will be implying 4x over x minus 1 is equal to 4y over y minus 1. You cross multiply, you have 4x into y minus 1 should be equal to 4y's into x minus 1. We expand, we have 4xy minus 4x to be equal to 4xy minus 4y's. So 4xy we can cancel out on both sides, and when we subtract them, we are left minus 4x equals minus 4y's and x equals y. So therefore, f is injective. F is injective. Now find the function, the composite function f of x and state its domain. So you are going to replace x in this function by f of x. So we have f of x will be equal to 4 f of x over f of x minus 1. This will be equal to 4 into 4x over x minus 1 over 4x over x minus 1 minus 1. We simplify that, we will have the numerator 16x over x minus 1. The denominator, we will have 4, that is 4 over x minus 1 minus x minus 1 over x minus 1, right? So we bring those terms together, this is what we have. And here the denominators are common, so we can just cancel out. We have 16x over 3x plus 1. And this function, they say you should state the domain. Don't bother to solve, they say state, they can still solve, no problem. So this function is defined if this denominator is not equal to 0. So if 3x plus 1 is not equal to 0, and you solve for x not equal to minus 1 on 3, so that's the domain. If you look at the equation they gave before, this is the same thing, right? So you can also add x an element of R, and x is not equal to minus 1 on 3. That's the domain of the function. The B part is on logic. So we have this logic. Two statements P and Q are given by P, the principal goes to the ministry, and Q, the principal will meet the minister. Write out the following proposition in ordinary English. This is P and Q, right? So the principal goes to the ministry and will meet the minister. That's the first one, right? That's the and statement. The principal will go to the ministry and meet the minister. I can equally write it like that. That's English. Then the second part is negation of P or negation of Q. You have to be careful with this one. I've made a truth table here to explain it. So we have P and Q. This is P, this is Q. Negation of P, negation of Q. So the negation of P or negation of Q is the same as the negation of P and Q. So this one is just equals the negation of this first statement, because this first statement is P and Q, right? So this second one is the negation of this first statement. So we write it as, and the negation of P and Q is written as not P or not Q, right? And but this statement is the negation of P or Q. So the negation of P or Q is not P and not Q. So we are using the second one, okay? So we have, you can use either two. So the principal does not go to the ministry or will not meet the minister, okay? The principal does not go to the ministry or will not meet the minister. The negation of P or Q, P and Q, okay, this is it here, as we have just mentioned. So that's what we have, okay? All right, so the negation of P implies negation of Q. Equally, the truth table tells us that this is what we have, the truth table. Negation of P implies negation of Q. So if the principal does not go to the ministry, then he will not meet the minister. So the principal does not go to the ministry. The principal does not meet the minister. So if he does not go, he will not meet the minister. Okay. Question 5, the equations of two lines are given by R equals that is I plus AJ minus K plus lambda into I plus 2J plus 2K, and R2 is AI plus 2K plus mu into minus J plus 3K, where mu and lambda are scalar parameters. Given that R1 and R2 intersect, find the value of the constant A. This is just 2019 again. The position vector of the point of intersection, and the cosine of the acute angle between R1 and R2. So this is on vectors. And if you go to GCE Math panel, we have some questions like this on vectors. Please go to GCE Math panel classes online. You will see most of these notes which we have for students. The notes are available in video form and in PDF. So you can go through the notes. If you don't understand something, you watch the video. Those are the lessons. And on GCE Math panel classes online, visit that page. We have further maths, we have chemistry, physics, biology. We have all of those subjects there. Just go there. Though the site is there, many students are not visiting it. If you don't know how to get there, just type www.gcemathpanel.blogspot.com and you click on the take me to that link. It will take you there. Don't forget to click on the subscribe there so that whenever you upload notes or videos or speco or whatever you call it, you can actually have access to them. And you can follow us on Facebook, because we also do broadcasting every Sundays. You send your questions, we answer them and broadcast them on Sundays, or on Mondays. You can equally send your questions, but visit www.gcemathpanel.blogspot.com. You have all this information there. So the equations of two lines are given by that and that. Find the value of the constant A. So since they intersect, means that line 1 is equal to line 2. So we equate the lines, right? So we can write them in column matrix form. R1 will be 1, the coefficients, right? So we have 1 plus A minus 1. So we have 1 plus A minus 1. Then plus lambda times 1, 2, 2, right? So plus lambda times into 1, 2, 2. Then this should be equal to the line 2, which is A2. That's A. The y component is not there, right? So the y component is 0. So we have the jth component. So we have A02. Then plus mu into, with this mu also the I component is not there. So we have 0 minus 1, 3. So we equate these two, right? When we open out, we have the equations. For the I component, we have 1 plus lambda is equal to A. That's equation 1. Then for the jth component, we have A plus 2 lambda is equal to minus mu, equation 2. And for equation 3, we have minus 1 plus 2 lambda is equal to 2 plus 3 mu, equation 3. So we can solve these three unknowns. But since this question wants us to find A, we can just look for A directly, right? So in equation 1, we make lambda the subject, and lambda will be equal to A minus 1. We substitute in equation 2. We will have A plus 2 into A minus 1 is equal to minus mu. When we simplify this, we'll have 3A's minus 2 equals minus mu. So here we have made mu the subject. So mu the subject becomes 2 minus 3A's. As we have made mu the subject, now we substitute in equation 3. This will give us minus 1 plus 2. Our lambda, original lambda is A minus 1. And then plus 2 into 3 mu, which is that. We simplify all of this. When we simplify this, we are going to have 11A's to be equal to 11, and A is equal to 1. 11A equals 11 and A is equal to 1. From here, the values of these other parameters now know that lambda should be equal to A minus 1, so 1 minus 1, which is 0. And mu, what is mu? Mu is equal to 2 minus 3A, so it's just 2 minus 3, which is minus 1. Now, the B part of the equation wants us to find the position vector at the point of intersection. For this position vector, we can just substitute the values of A and mu into the equation that requires a and mu, or the ones with a and lambda. So this will give us for the position vector, which is R0. We can use the first equation. We will have 1, 1 minus 1, because a is 1, right? Plus lambda. The lambda value at the point of intersection is 0, right? All right, so this gives us 1, 1 minus 1, because lambda is equal to 0. Then we can equally use the second one. You can use R2. You still have the same result as you can see. We have our a is 1, so we have 1, 0, 2, plus our mu is minus 1 into 0 minus 1, 3, right? So minus 1 here, 15 minus 1 here, and simplifying. We have 1, 1 minus 1 as well. And this is because mu is equal to minus 1. Now find the cosine of the acute angle between R1 and R2. For the cosine of this acute angle, we need to find the magnitude or modulus of each of the direction vectors. Note that when you're finding the cosine of the acute angle, you use the direction vectors. Like here for the vector R1, the direction vector is 1, that is I plus 2j plus 2k. And the second vector, the direction vector is minus j plus 3k. That is what we are using to find the cosine of the acute angle, okay? So we have to look for their magnitude. So for the first one, the magnitude of I plus 2j plus 2k is 1 squared plus 2 squared plus 2 squared, which is the square root of 9, which is equal to 3. And for minus j plus 3k, the magnitude is, or the modulus is root 10. So we have 0 squared plus minus 1 squared plus 3 squared, that is equal to root 10. And then we now look for the dot product of these two direction vectors. So we have 1, 2, 2 dots, 0 minus 1, 3. So this will give us 0 times 1 plus 2 times minus 1 plus 2 times 3. So that gives us a value of 4. And how do we get the cosine of this angle? Cos theta is equal to a dot b, where this a is the first direction vector, b is the second direction vector, a dot b over mark a mark b. A dot b is equal to 4 over mark a mark b is 3 root 10. So this is the direction of the cosine of the acute angle, right? This is the cosine of that acute angle between these two vectors. Guys, don't forget to subscribe. If you don't subscribe, there will be no way for you to watch paper 2. And equally, you can visit our page every day at www.gcemathpanel.blogspot.com, where you have past papers and answers. You can equally follow us on Facebook, where we post all of our announcements, our links, our lessons, our PDF, everything, SPECOs, and so on, and other groups of the GCE. And our channel on YouTube is www.gcemathpanel. I'm sorry, it is GCE Math Panel on YouTube. There you can find everything that we have done. For some of the videos or lessons which you have hidden, you can find them on our GCE Math Panel online classes, or you still go to www.gcemathpanel.blogspot.com. Economics, geography, history, chemistry, physics, all of that. You get all of the stuff there, okay? Stay tuned. Question 6. Evaluate the integral from 0 to pi on 3 of cos 3x to the power 4 sine 3x dx. Note that cos to the power 4 of 3x is the same as cos 3x, all that to the power 4. B, find the volume of the solid generated when the curve y equals x cubed is rotated completely about the x-axis between the ordinates x equals 0 and x equals 3. All right, so let's evaluate this integral first. So we can if you look at this integral, if you differentiate cos 3x, you have minus 3 sine 3x, right? So we can let our u be equal to cos 3x. So let u be equal to cos 3x, and du will be equal to negative 3 sine 3x dx. We can now copy out we can now solve for sine 3x dx because we see it in this integral. This is sine 3x dx. So we can make sine 3x dx the subject, and sine 3x dx will be equal to minus 1 on 3 du. Now we equally know that cos 3x, all of that to the power 4 will be equal to u to the power 4. So this integral will give us, of course, 3x to the power 4 sine 3x dx will be equal to the integral of u to the power 4, this u to the power 4, and sine 3x dx, as we already know, is minus 1 over 3 du. So this gives us a du times minus 1 over 3. You can carry you can put the minus 1 over 3 outside the integral sign, okay? So we integrate this now. We will have minus 1 over 3 u to the power 5 on 5 plus a constant. I'm not going to put a constant because this is definite integration. So this integral now will be minus 1 on 15 cos 3x to the power 5 from 0 to pi on 3. When you integrate this, what we are going to have. These are the limits of integration. So when you integrate that, that's what we are going to have. Now, upper limit minus lower limit, we have minus 1 on 15 into 3 times pi on 3 is pi. Because pi is minus 1. Minus 1 to the power 5 is minus 1, right? And then we have 0, because 0 is 1. So this gives us minus 1 minus 1. And this integral is 2 on 15. The integral here is 2 on 15. Yes, it's always very simple. When the teacher has done it, the teacher always does a simple example. Even when the teacher does the most difficult ones, students will see that the teacher did the most easy one or the easiest one. Now let us find the solute of this figure generated when this curve y equals x cubed is rotated completely about the x-axis between the ordinates x equals 0 and x equals 3. So this volume is defined as the integral from a to b of pi y squared dx. This is the integral we are looking for the volume of solid of revolution about the x-axis. Our a here is equal to 0 and our b is equal to 3. Our y is x to the power 3, right? So this will give us the integral from 0 to 3 of pi x to the power 3 all squared dx. So this is the integral of pi, the integral from 0 to 3 of x to the power 6 dx. So this will be equal to pi into x to the power 7 on 7 from 0 to 3. And this will give us pi on 7 into 3 to the power 7 is 2187 minus 0 to the power 7 is 0. So this gives us 2187 pi on 7. So that's the volume of the solid, and we have this volume in cubic units. The volume of the solid of revolution about the x-axis from x equals 0 to x equals 3 of the curve y equals x cubed. That's the solid, the volume of the solid of revolution. Okay. Let's move to question 7. Show that the equation f of x equals 0, where f of x equals 3x cubed minus x squared plus 3x minus 1 has a root between 0 and 1. If you have an issue with this lesson, you can go to our GCE Math Panel online on YouTube. This particular lesson is found in advanced level polynomials. You have answered this in polynomials. The lessons on polynomials, how about 4 lessons on polynomials? We have answered this day. And we show how a function has a root between a value of a and value of b, right? The second part of the equation reads, given that the parametric equation of a curve are sine 2 theta for x and y equals cos 2 theta, find the squared y on the squared x in terms of the parameter theta, And sub 3, show that the function f is such that R is mapped onto R, the set of real numbers, where f of x equals 2x plus 5 to the power 3 plus x is an increasing function. Let's see how we answer these questions, beginning with the show that the equation that has a root between the 0 and 1. So a function has a root between 0 and 1 if f of 0 times f of 1 is equal to or is less than 0, is negative or less than 0. So we have to look for f of 0. Our f of 0 here will be equal to 3 into 0 to the power 3 minus 0 squared plus 3 into 0 minus 1. And what does that give us? Minus 1, right? Now, what is f of 1? F of 1 will be equal to 3 into 1 cubed minus 1 squared plus 3 into 1 minus 1. And that gives us 4. Now, f of 0 times f of 1 will be equal to minus 1 times 4, which is minus 4. And this minus 4 is less than 0. This minus 4 is less than 0. Therefore, we conclude that f has a root in the interval 0 to 1, or between 0 and 1. Then sub 2. Given that the parametric equations of a curve are x equals sine 2 theta and y equals cos 2 theta, find the squared y over dx squared in terms of the parameter theta. So this is parametric differentiation. We are going to answer this question in two ways. Can answer this question in two ways. The first one is working with parametric differentiation for second derivative. We know that dy dx is the same as dy d theta on dx d theta, or you can write dy d theta times d theta dx. This is the same thing. And if you have to have d squared y over dx squared, this will be equal to d theta of, that is d theta, look at it very well, d theta of dy dx, that is it, all that on dx d theta, all that on dx d theta. And this is how you have the theta here. Look at this is theta and this is theta. But this one here is dy dx matching with this d squared y dx squared. So we can use this formula, right? So let's use this one first, the first method. So this is it here. So dx d theta here will be equal to, when you differentiate sine 2 theta, you have 2 cos 2 theta. So dx d theta will be 2 cos 2 theta. And when you differentiate cos 2 theta, you have minus 2 sine 2 theta, okay? Minus 2 sine 2 theta. Now let us look for dy dx. Our dy dx will be equal to, because according to this formula, you now need dy dx before you can differentiate this one, right? So I need this dy dx to now differentiate it. So dy dx will be equal to dy d theta on dx d theta. That gives us minus 2 sine 2 theta on 2 cos 2 theta, which is equal to minus sine 2 theta on cos 2 theta. You can write tan 2 theta, right? But I don't want to write it because I want to use the quotient rule. I want to leave it like this so I can use the quotient rule here. Now, what will be d squared y over dx squared? It will be d theta of this our dy dx here. So this will be equal to, so we start by looking for d theta of dy dx, right? So this gives us bottom constant for this one, that is cos 2 theta. We differentiate the top, we have minus 2 cos 2 theta, right? Now minus the top constant, that is minus sine 2 theta. Now minus the top constant. We differentiate the bottom. When you differentiate the bottom, we are going to have minus 2. Oh yeah, bottom constant differentiate the top, minus the top constant now, minus, so we have 2 minuses here. Minus the top constant will differentiate the bottom. You have 2 minuses. This minus is inside here. Differentiate the bottom. All this on the bottom squared. So you have cos 2 theta all squared. So this gives us minus 2 into cos 2 theta squared, this is it now, cos 2 theta plus sine 2 theta all squared. This is the minus you have factorized because minus times minus times minus is minus. So we factor it out. And this will give us that. But we know that cos squared 2 theta plus cos squared plus sine squared 2 theta is equal to 1. So this gives us minus 2 over cos 2 theta all squared, or cos squared 2 theta, as can write it. So what will be our d squared y on the x squared now? It will just be equal to this value divided by the x d theta, or the x d theta is 2 cos 2 theta. So this will be equal to minus 2 on cos 2 theta all squared divided by the x d theta divided by 2 cos 2 theta. And that will give us minus 1 on cos 2 theta to the power 3. Cos 2 theta to the power 3. So this is the value that we have for this first method. Let us look for another method that we can do the same thing. So alternatively, we know that we can convert this. This is like this equation of a circle with radius 1. We know that x is equal to sine 2 theta and y is equal to cos 2 theta. If we square both sides, we will see that x squared plus y squared is equal to 1, right? Yeah, because sine squared theta plus cos squared theta is equal to 1. So therefore, x squared plus y squared will be equal to 1. Then we now differentiate, implicit differentiation. We differentiate 2x with respect to x, x squared with respect to x, we have 2x dx, plus differentiating y squared with respect to y, we have 2y dy, and we differentiate 1, we have 0. So we simplify this, we'll have dy dx will be equal to minus x on y. So now for second derivative, you can differentiate this dy dx, right? So the squared y over the x squared will now be equal to, keep the bottom constant y. You differentiate the top, you have minus 1. Now minus the top constant, so minus x constant, differentiate the bottom. Be careful here, this function is a function of x and y in terms of x and y. So when you differentiate this y here, you have dy dx. All this on the bottom squared, all that on y squared. Okay. Yeah, some of you like to say the buttock squared, but please, not buttock squared. That's what students taught me in class, but I'm not using that. I don't know, they always hear some type of things instead. So this gives us minus y plus x. We can now replace this y x here by minus x on y, right? That's what we have here. All that on y squared. And this will give us minus, we simplify numerator, we'll have minus y squared plus x squared on y, all that on the denominator. So this can be further simplified to give us minus 1 on y for the numerator, because we know that x squared plus y squared is equal to 1. From this first line here, x squared plus y squared is equal to 1. So we can replace this with 1. We have minus 1 on y squared, and this gives us minus 1 on y cubed. But it's not any because we have been told to give our answer in terms of the parameter theta. So I'm going to replace y cubed by, I'm going to replace y in this equation by the y value in terms of theta. So this gives us minus 1 over cos 2 theta to the power 3, or cos cubed 2 theta. Cos cubed 2 theta. So this is another method. So you can choose one of them and you use the one that you think you can easily work with. You choose that one and work with it, okay? Don't forget to subscribe before you watch paper 3, because without subscribing, you'll not be able to watch paper 3. And when you subscribe, also click on the notifications. Notifications will notify you immediately the lesson is uploaded or the video is made available immediately. So you have to make sure you subscribe and share this video and leave your comments. Let us know what you think. Leave your comments. Share your likes and dislikes. Tell us what you think about the video. Tell us the issues you have found out with. It's very important. Otherwise, we might not know where we are all moving to. We should not be making sense. Now, the last part of the question says that we should show that this function, where R is mapped onto R, is strictly an increasing function. A function is strictly increasing if its gradient is always positive. That is, if the derivative of the function is always positive, right? So if the gradient function is always positive, we have to look for dy dx, and that will give us, you bring down the power 3, differentiate the core, differentiate this core 2x minus 5, you have 2. Now times the function itself and subtract 1 from the power. So times 2x minus 5 to the power 2. And when you differentiate x, you have 1, right? Now when you look at this function, this 2x minus 5 is always positive. 3 is positive, 2 is positive. So all of this function is always greater than 0. So this function is always, in fact, the smallest value that this function can take is when this is equal to 0, and that smallest value is 1. So this function is always positive. Therefore, f is strictly an increasing function. So f is strictly increasing. All right, question 8. The sum of the first and second terms of a geometric progression is -5, while the sum of the fourth and fifth terms of the same progression is 40. Find the first term and the common ratio of the progression. The B part, find the term independent of x in this expansion. Yes, this question was one of the toughest questions that disturb students during the GCE. And this type of questions have the tendency of repeating. If you look at 2019, you see a similar question like this, the A part of this question. And many students had a lot of issues here, a lot of issues. We are going to give you a shortcut and an easier way to answer this type of question. So you have been told that the sum of the first two terms is -5. You know, the first term is a, the second term is a plus, that's the second term is ar. So we have our a plus ar to be equal to 5. And we have been told that the sum of the fourth and fifth terms of the same progression is 40. The fourth term is ar to the power 3, as you know, right? And the fifth term is ar to the power 4, and this is equal to 40. So for each of these two equations, we factorize such that we have 1 plus r in both. Like the first one, equation 1, we factorize this, we have a into 1 plus r because a is common. And the second one, you see that ar to the power 3 is common. So we have ar to the power 3 into 1 plus r. And at this point, it's very easy to divide both equations and solve for r directly. So we now say equation 2 divided by equation 1 will give us, so when you divide, you have 40 divided by 5 is 8. This 1 plus r will cancel out 1 plus r. A will cancel out with a, will be left with r to the power 3. And so therefore our r is equal to 2. As easy as ABC. All the other methods will only give you stress. Avoid them. Use this short straight method, okay? Okay, so this is the common ratio of the progression. Now, how do we get the first term? You just substitute this in any of the equation, like in equation 1. We will have, since our r is 2, we will have a plus 2a, which is 3a is equal to 5, and a is equal to 5 on 3. This equation that students will spend about 15 minutes just to answer this part, and they will end up not having the answer. Look at how short and simple it has been. Use this approach for this type of questions, okay? Now the B part said, and look at it, 6 marks. Find the term independent of x here. The general term is given by CR plus 1 is equal to n combination r, a to the power n minus r, b to the power r. Now for the term independent of x, we are going to have 15 combination r. Our a here, this first part of this is x, right? So we are using one as our a. So we have x 15 minus the power 15 minus r. And our b here is 2 over x squared. So we have 2 over x squared to the power r. So this is what we have. We simplify it. We have x to the power 15 minus r times, this is 2. You can write this x to the 1 over x to the power 2 or raise the power r as x to the power minus 2r. Can you see? So you can write that this 2x to the power minus 2r. The terms with x to the power something is of our interest. So the general term will be given by this 15 combination r, 2 to the power minus 2r, x to the power 15 minus r minus 2r. So this gives us x to the power 15. Now, if the term independent of x, this x to the power whatever will be equal to x to the power 0. So this is our focus. The term independent of x, this 15 minus r minus 2r should be equal to 0 because the term is independent of x. So we have 15 to be equal to 3r, because I have 15 minus r minus 2r equals 0. So 15 is equal to 3r and r is equal to 5. So this will be the term independent of x. Therefore, that term independent of x is the sixth term actually. So our t will be equal to, that term will be equal to 15 combination 5. You now put in the formula times 2 to the power minus 10 times 2 to the power minus 10. We are not using this x to the power whatever because all of this is equal to 1, right? X to the power 0, which is 1. So this term independent of x will be equal to 15 combination 5 times 2 to the power 2 into 5. That's 2 into minus 2 into 5. And this gives us 3003 on 1024. So that is the term independent of x. Question 9. Given the complex numbers z1 equals 4 minus 5i and z2 equals p plus 4i, where p is an element of R, find the value of p for which z1, z2 bar is purely imaginary, where z2 bar is complex conjugate of z2. Hence, find the absolute value of z1 and the argument of z2 squared. The B part, given that z is equal to x plus iy, where x, y are elements of the set of real numbers, find the locus of the point z such that max z equals z minus 2 plus 2i. Yes, this question also troubled a lot of students, and we have been receiving a lot of messages from WhatsApp and from the link in www.gcemathfinder.blogspot.com asking us to answer these questions. Students have been sending this question so many times. So students equally had a lot of difficulty with this question in the exam. But this question is quite easy. It's quite easy. So given this complex number z1 and z2, to find the value of p for which this z1, z2 bar is purely imaginary. So the complex number to be purely imaginary or purely imaginary, what does that mean? If it is purely imaginary, it means that the real part is 0, because the complex number is an imaginary one. It's just imaginary. Therefore, means that the real part is 0. That is the idea we use to answer this part. So here we have z1, z2 bar. Note that our z2 bar here should be p minus 4i, because it says z2 bar, the complex conjugate. So that will be equal to 4 minus 5i times p minus 4i. Okay. So when we expand this, we will have 4p's minus 16. That's 4p's minus 16i's minus 5p's minus 20. Okay, let me look at this one again. So we have 4p minus 16i minus 5pi minus 20. So if we bring the like terms together, so we have 4p minus 20 minus I into 16 plus 5p. So if this complex number is purely imaginary, it means that this real part is equal to 0. Since it's purely imaginary, it means the real part equals 0. So we have 4p minus 20 to be equal to 0, and our p is equal to 5. Our p is equal to 5. Hence, find the absolute value of z1, that's the modulus, right? So max Z1 will be equal to, we have 4 squared plus minus 5 squared, the square root of that. That will give us the square root of 41. That is 16 plus 25, which is the square root of 41. Then find arc Z2 squared. So for arc Z2 squared, we can first of all decide to look for Z2 times Z2, which will give us a Z2 squared, and then you look for the argument. Or we can decide to use the formula that arc Z to the power n is equal to n arc Z. So we can look for arc Z for this one, arc Z, which is you have 5 plus 4i, right? So the argument of this complex number will be equal to 2 times arc tan 4 on 5, y component of x component. That will give us 2 into 0.675 radians, which is 1.35 radians approximately. So that is the argument of this complex number. Don't forget to subscribe and share this video. You can visit us on www.gcemathspanel.blogspot.com, where you get past papers, corrections, speculations, preparations, and all sorts of preparations for GCE are there. We have Black June, we have examiners bad hand, we have physics, chemistry, biology, maths. We have all stuff. You can visit us on Facebook and our live videos. We have advanced level classes mostly on Friday, on Saturdays, Sundays, and Mondays online. You can check that from our website or on GCE Maths Panel classes online. Let's answer the second part of this question, which states that given that Z equals x plus iy, where x and y are elements of the set of real numbers, find the locus of the point Z such that max Z is equal to max Z minus 2 plus 2i. So let us do this one. So we actually apply what we have here. We have been told that Z is equal to x plus iy. So we have Mac. The modulus of x plus iy should be equal to the modulus of x plus iy minus 2 plus 2i. On the right-hand side, we will have x minus 2, that's the real part, plus the imaginary part, I into y plus 2. Now the modulus for the left-hand side, I have x squared plus y squared square root, but there will be no need for us to put square root because we take the square root on both sides. We still have to cancel it out. So we have x squared plus y squared should be equal to x minus 2 squared plus y plus 2 all squared. We open out these brackets and simplify. We have x squared plus minus 4x plus 4 plus y squared plus 4y plus 4. And these terms will cancel out x squared on both sides as well as y squared. We are left with minus 4x plus 4y plus 8 equals 0. We bring like terms together. And this gives us an equation of a line. When we simplify, we have y is equal to x minus 2. So this is an equation of a line with gradients, positive 1, which is the coefficient of x, and the y-intercept is minus 2. So the locus of this point, Z, is a line with gradient 1 and intercept minus 2. That is it for question 9. We can now look at the last question. Have you subscribed? Before we look at the last question, if you have not, click on the link below this video and subscribe. With question 10, there are multiple approaches to answer this question. We have just looked at one. Find the value of the constant k for which the matrix A is singular. So a matrix is singular if the determinant is equal to 0, right? B, find the inverse of this matrix B. Hence, solve the system of equations. Find the image of the point minus 2, 3, 1 under the transformation matrix defined. So question 10a, for question 10a, let's see how we get to this question. Question 10a. So a matrix is singular if the determinant is equal to 0. We can use other methods to get this determinant. Let me use this method. Here the determinant will be given by So you write out this matrix, then you copy out the first and second columns again. So you copy out 2, 1, 5, this is it, 3, minus 1, 0. Then now we get the product of each of the diagonal lines. So 2 times minus 1 times k, that gives us minus 2k. 3 times 2 times 5 gives us plus 30. 4 times 1 times 0 gives us 0. So the sum of all of this now minus, you now take the off diagonals from bottom left. You have 5 times minus 1 times 4. That gives us a minus 20 plus 0 times 2 times 2, 0, plus k times 1 times 3, which is 3k's. So this is going to give us the determinant of the matrix, right? So this determinant should be equal to 0 because they said the matrix is singular, right? So this is going to give us minus 2k's plus 30 plus 2k minus 3k equals 0. From there, 50 will be equal to 5k's, and we will have our k to be equal to 10. Another method is this second one. We can use this one, so we can use the minus and cofactors, the cofactors rather. So we have a 2 we have minus 1, 2, 0k. Then the next position is 3, which is going to be minus 3 into, you suppress this row and column. So we have 1, 2, 5k. The last one is 4, which is positive. You suppress this row and column where 4 is found. You have 1 minus 1, 5, 0. If you have issues on this, please watch the videos on matrices. It is written further math, but it's not further math, it is math. On this same channel, further math, you have determinants of 3 by 3 matrices. This is well explained there, all of these methods. It is written further math, but it is actually a math video. So since it's equal to 0, this determinant will give us the same value, and k will also be equal to 10. So open this, we have 2 into minus 1 times k minus this. So we have 2 into minus k, which is minus 2k. Minus 3 into 1 times k is k minus 2 times 5, which is 10. So we have minus 3 into k minus 10. That will give us minus 3k plus 30. Then plus 4 into 1 times 0 is 0, minus 5. It's 5 times 4, 20. That should be equal to 0. So we have the same result, the two methods. Now we have to find the inverse of that matrix. We need to look for the inverse of the matrix. This is the matrix above here. To find the inverse of this matrix, be very careful. Though your k here is equal to 10, this is a different equation now. According to this equation now, our k is 2. That's the value we are going to be using. Because if the matrix is singular, then we cannot look for the inverse. Therefore means that the B part will have no answer. Yes, a singular matrix has no inverse. Because when the determinant is 0, there's no inverse. So our k here, according to this equation, is equal to what? It's equal to 2. So now we can look for the determinant. We already have this line here. We can copy this line and use. We already have the determinant. Our determinant will be equal to minus 2k. We can replace the k by 2 because the k here was something, it was k. Or we can use this same approach again to get the determinant. So this will be equal to minus 2 into 2 plus 30 plus 20 minus 3 into 2. The determinant gives us 40. 40 for the determinant. Then we have to now look for the adjoint of the matrix, because to have the inverse, we need the adjugate or the adjoint and the determinant. So the adjoint B star is given by the transpose matrix of cofactors. So we are going to come to this matrix that we have and get the cofactors. Like we use the this is the method of cofactors here. We get the cofactors. So the first cofactor is going to be a positive factor. So we have plus. The cofactor here is, first cofactor is obtained by suppressing the rows and columns. Suppress this row and column where this matrix is found. So we have minus 1, 2, 0, 2, because our k is 2. Minus 1, 2, 0, 2. The next cofactor, this position should be negative. The signs alternate. So we suppress this row and column. We have 1, 2, 5, 2. The next cofactor is here at 4. It's now positive. We suppress the row and column. We have 1 minus 1, 5, 0. If If you don't like this method, you can use Cramer's rule to find the inverse of a matrix directly. You can equally get this video, or you visit GCE math panel classes online. You will see Cramer's rule to find the inverse of a matrix is very easy also. Though this one is a bit more difficult. The Cramer's rule is very easy. The next cofactor should be negative. At this position, we suppress this row and column. So we are going to have 3, 4, 0, 2. Note that our k is 2 in this case. So we have 3, 4, 0, 2. Next cofactor is positive. We suppress the row and column. We are going to have 2, 4, 5, 2. Next cofactor is here. It is going to be negative. We suppress this row and column. We will have 2, 3, 5, 0. The next cofactor is here. It's going to be positive. We suppress the row and column. We will have 3, 4, minus 1, 2. Next cofactor is at this position. We suppress the row and column. We will have 2, 4, 1, 2. And the last cofactor is here. It's going to be positive. We suppress that row and column. We have 2, 3, 1, minus 1. So we look for all of these determinants. Minus 1 times 2 minus 0 times that. So we look for all of this and transpose. Don't forget the transpose. So when we do this, we are going to have the transpose of 2, 8, 5, 6, minus 16. This one here, we have 2 times 0, 0, minus 15, minus 15 is plus 15. Then we have 3 times 2, 6. 6 minus 4, 10. Here we have minus into 2 times 2, 4, minus 4. This is 0. This position, we have 2 times minus 1 is minus 2, minus 3, minus 5. When we transpose this, we are going to have the adjoint of this matrix. That's going to give us, we interchange rows for columns. So we have minus 2, 8, 5 becomes a column now. So, or we say minus 2, minus 6, 10 becomes a row. Minus 2, minus 6, 10. 8, minus 16, 0. 5, 15, minus 5. So that's our adjugate, right? From here, we can now have the inverse of this matrix. The inverse of this matrix, the inverse will now be given by 1 over the determinant times this adjugate. So that's the adjugate that we had, and that's the determinant. So the inverse of the matrix is equal to 1 over the determinant times the adjugate. That's the inverse of that matrix. Now we can find the image of B. Can find the image of B, but there is a system of equations that we also need to solve. Okay, so normally this is the inverse of this matrix, right? Okay, now let's solve that equation that's been given. Hence, solve the system of equations. This, if you look at the coefficients of the x, y, and z in this matrix, you see that it is the matrix B, right? So that's matrix B times x, y, z. So we write it in this form, should be equal to the matrix on the right hand side, 1, 2, 5. So this is the matrix B, this is the matrix X, and this is the constant matrix. From matrix properties, we can solve X, Y, and Z by using this procedure. Let us take analysis. So we have B times X is equal to C. If we pre-multiply both sides by B inverse, we are going to have B inverse times BX is equal to B inverse times C. But B times B inverse is going to give us the identity matrix here. And the identity matrix times X leaves X the same. So that's going to give us X to be equal to B inverse times C. It therefore means that to solve for X, Y, and Z, we just need to pre-multiply this constant matrix by the inverse of B. So that's what we're going to be doing. X, Y, Z will be equal to, that is the inverse, B inverse, right? Times that constant matrix there. And when we do this multiplication, we are going to have 9 on 10, minus 3 on 5, and 1 on 4. So those are the values of X, Y, and Z. You can do it and you have these values. Okay. The last thing is to find the image of this point. The image of this point is just obtained by pre-multiplying this point by the inverse matrix. All right, I'm sorry, by pre-multiplying this point by the matrix B. So to find the image of this point, so as you said, the image of this point can be given by pre-multiplying this point by the matrix B. So this will give us 2, 3, 4, 1 minus 1, 2, 5, 0, 2 times minus 2, 3, 1. And this will be equal to the matrix with points 9 minus 3 minus 8. So that's the image of the point defined by the matrix B. That's the image of that point defined by the matrix B. Thank you guys so much, and don't forget to subscribe and also watch paper 3. We have a lot more for you. If you need a personal tutor and you are financially able, I repeat, and you are financially ready, then you can get to us. If you're not financially ready, please don't get to us. Please, we are begging you, don't. So you can get to us through this number on screen on WhatsApp only on WhatsApp. Visit our blog on www.gcemathpanel.blogspot.com, and don't forget to subscribe. We thank you so much, and we beg you to leave your comments, to share this video as much as possible to all WhatsApp groups or Facebook groups, all groups to which you belong, and leave your comments as your friends to subscribe, so you continue to motivate our team, because the more they see students using the videos, the more they are motivated to work. We thank you so much, and we wish you the best. Don't forget to join our online preparation classes, and you can get to us using the WhatsApp number or visiting our blog, or get to GCE Math Panel classes online. Thank you so much. Don't forget to watch paper 3. Hello guys, welcome once more back to our channel. And in today's lesson, we are looking at the correction of Math Statistics, June 2021, paper 3. Guys, please make sure you watch this paper to the end, as we have a lot of hints which we are going to present to you. And as well, don't forget to subscribe as we begin this video, to share and to leave your comments. Most importantly, when you subscribe, don't forget to click on the notifications bell, so that when you upload other corrections, be it mock or other past papers, you are instantaneously notified in your email. Stay tuned with us, and let's roll. So the first question here reads, the table below shows the time in minutes spent by a set of 80 customers at the customer service of a certain credit union. So this is the time ranges, and here we have the number of customers. The first question is to calculate 3 decimal places the mean time spent by the customers at the customer service. B, the standard deviation of the time spent by the customers at the customer service. And we are being introduced to the C and D part by this paragraph. It was observed that the mean and standard deviation of the time spent by a second set of 20 customers at the customer service of that credit union were 21.037 minutes and 8.312 minutes respectively. Calculate again to 3 decimal places. The first was 3 decimal places, now to 3 decimal places. The mean time spent by the combined set of 100 customers at the customer service, and the variance of the time spent by the 100 customers at the customer service. So here is a table that represents this problem, and we proceed as follows. The first part warrants us to calculate to 3 decimal places the mean time spent by the customers. So here I'm going to add another table here, and since these values of x is a range of values, we are going to use the mid interval. So 1 plus 5 divided by 2 is going to give us a mid here 3. 6 plus 10 divided by 2 is going to give us 8. Here, 11 plus 15 on 2, 16 plus 20 on 2, 21 plus 25 on 2, 26 plus 30 on 2, and 31 plus 35 on 2. Finally, we have 38 for the last place. Now, we know that the formula for mean is the statistic times its frequency, right? So x bar is equal to the summation of each of the statistics times its frequency divided by the sum of frequency n. So we can equally add another part of this table here where you have xf is statistics times its frequency. So we will have 3 times its frequency, that's 9. 7 times 8 is 56. 12 times 13, 156. 16 times 18, 288. 20 times 23 is 460. 10 times 28 is 380. 8 times 33 is 264. And 4 times 38 gives 152. So if you sum all of these, we are going to have 1,665. So replacing this or substituting this in the formula, we'll have 1,665 on 80, because there are 80 students, as we are told in the equation. And this gives us 20.813 minutes. And the answer is supposed to be to 3 decimal places. Now, the B part of the equation is to calculate the standard deviation of these customers. So the standard deviation is given by the square root of variance. So we start by getting the variance, and the square root of that variance gives us the standard deviation. How do we calculate standard deviation? It is the summation of the squares of each deviation times its frequency, all that on the sum of frequency. So xi minus x bar squared times the frequency of xi, all that on n. So here we are going to start by looking for the deviations. So for each of the deviations that we have, we square and multiply by the frequency. In the first case, we will have this mean value. So 3 minus the mean. The mean is, what's the mean value that we have? So the mean is 20.813, okay? So we are going to have 20, that's 3 minus 20.813 squared times the frequency. The frequency is 3. This gives us 951.8555. Why am I taking it to 4 decimal places? I'm taking to 4 decimal places because at the end, I would like to approximate my answer to 3 decimal places. If it takes 3 decimal places, it's still okay. And since the first part of the equation wants me to give my answer to 3 decimal places, it will be good that I draw the line for the B part of the equation. And the second one, the statistic is 8. So we have 8 minus 20.813 squared times its frequency, which is 7. So this gives us 1,149.1211. The next statistic is 13 minus 20.813 squared times 12. That's what we have. And then we have 18 minus x bar, that is 18 minus 20.813 squared times the frequency of 16. And then we have 23 minus 20.813 squared times the frequency of 20. And here we have 28 minus 20.813 squared times the frequency of 10. That gives us 516.6016. And 33 minus 20.813 or squared times the frequency, which is 8. That gives us 1188.2813. The last one is 38 minus 20.813 times squared times this frequency of 4. And we have 1181.6406. If we sum all of these, we are going to have 5,942.1876. Therefore, our variance would be equal to this value divided by, we had a total of how many statistics? 80. So divided by the sum of frequency, which is 80. This gives us the variance. But remember, we are not looking for the variance. We are looking for the standard deviation. So the standard deviation equals the square root of the variance, that's a sigma, which gives us 8.618. The answer is also 3 decimal places. Now we are introduced by a paragraph to the next part. If you don't have this paper, please go to our blog, www.gcemathpanel.blogspot.com, and you will obtain a copy of this paper under advanced levels. So the B part of the question reads, it was observed that the mean and standard deviation of the time spent by a second set of 20 customers. So for this second set of 20 customers, we have the mean and standard deviations to be respectively 20.037 and 8.312 minutes respectively. So the combined mean will now be equal to, this is what we are going to do. We will take the mean for this first statistic, that's of these first 80 students. The mean is 20.813. That mean multiplied by the number in this first group. So we have 20.813 times 80. Now plus for the second group, there are 20 clients or customers. And this question gives us their own mean as well. For this second group, the mean is 21.037. So, and times 20. So let's see what we have. So we have 80 times this mean for this group, 20.813. For the second group, we have 20 times, all right, please take note, the bar is not there, the bar is not there. So 20 times 21.037, and the sum now of this combined group is 100. Simplifying this will give us the new mean to be 20.858 minutes. And I'll still give my answer to 3 decimal places as it is throughout the question. No, now, so this is the combined mean, that's C, and D, they want us to find the variance of the time spent by the 100 customers. So here they want to give us, they want us to give the combined variance. So the combined variance as well will be equal to the variance of group 1 times the frequency of group 1 plus the variance of group 2 times the frequency of group 2, all that on the sum of the frequencies. So this gives us 80 into 74.277 plus 20 into 8.312, all of that squared. Why do we have square here? Yes, we have squared here because we have used 8.618, okay? So if we did not use 8.618, then we should use this value of 74.277345. I did this because sometimes in the equation, they give us the standard deviation and we forget and we use that standard deviation directly at this position. Note, here you're supposed to use the variance. So when you square this standard deviation, you have the variance. This same value you have on the left-hand side. So this combined variance is going to be 73.239 minutes. That's the variance. So this is it for question 1, guys. Please, if you love our videos, just leave a comment below and click on the like button. When you subscribe, don't forget to click on the notifications bell, because without clicking on the notifications bell, it will just be like going for the party and not attending the party, because when you upload a new video, you will not be notified. This brings us to question number 2. So guys, now welcome to question number 2. In this question, we have A and B are 2 events such that P of A equals a half and P of B complement is equal to 5 and 6. The probability of A union B is equal to 5 and 12. The first part of the equation, find the probability of A intersection B. Then the probability of A given B complement. Sub 2, a bag contains 3 red balls, 2 white balls, and a blue ball. 2 balls are drawn at random from the bag, one after the other, without replacement. C, draw a tree diagram to illustrate all the possible outcomes of the draws. Hence or otherwise, find the probability that a blue ball, and a white ball are drawn. E, the second ball drawn is red. So we start by looking at the probability of A intersection B. According to the third law of probabilities, the probability of A union B is equal to the probability of A plus probability of B minus the probability of A intersection B. So making the probability of A intersection B the subject of the formula, let's see what we are going to have. And equally recall that the probability of A given B complement is the probability of A intersection B, or that on probability of B complement. Let us dive into the equation. So the key is to answer more questions. So from the third law of probabilities, we have the probability of A intersection B to be equal to the probability of A plus the probability of B minus the probability of A union B. The probability of A given to us was a half. The probability of B given to us, according to the equation, for the probability of B, we had a 1 on 5 on 6. That was the probability of B complement. So the probability of B should be 1 minus the probability of B complement or B prime. Okay, so the probability of B complement was given to us as 5 on 6. Therefore, the probability of B is 1 minus 5 on 6. And of course, the probability of A union B was given as 5 on 12. Looking for the LCM and simplifying this gives us the probability of A intersection B to be a quarter. The B part of the equation wants us to find the probability of A given B complement. So the probability of A given B complement is equal to the probability of A intersection B complements, all that on the probability of B complements. So that's what we have. So equally, we know that the probability of A intersection B complement is the same as the probability of A minus the probability of A intersection B. In one of my previous videos, I explained this. In one of the past years, I explained this very well. And equally, the probability of B complement has been given, so we can put it here directly. So note, the probability of A intersection B complement is equal to the probability of A itself minus the probability of A intersection B. So this will give us probability of A, which is a half, minus a quarter, all that on 5 on 6. So our result is equal to 3 on 10. That's the probability of A given B complement. Now, with the next part of the equation, we are told that a bag contains a certain number of balls, of which 3 balls are red. So we have 3 red balls, and we have 2 balls which are white. We have 2 white balls out of 6 and 1 ball that is blue. So this is what we have in this bag. And they want us to draw, the first thing is to draw the tree diagram that illustrates the possible outcomes of this draw. We are equally being told that when a ball is drawn from the bag, it is not replaced. So the bag contains 3 balls which are red, 2 which are white, and 1 which is blue. So altogether there are 6 balls. So this is for the first draw. So for the first draw, if the first ball is red, then how many red balls will be left in the bag? 2 out of how many balls now altogether? Out of 5. So the sample space decreases when we work without replacement. So if the first ball is red, we will have how many red balls left? We will be left with 2 red balls out of 5. The number of white balls will remain untouched. So we'll still have 2 out of 5, but the sample space has reduced. And the number of blue balls will still be 1 on 5 balls. However, if the first ball was white, then how many balls will be left to the second draw? The number of balls left in the second draw will be 5, of which we will now have only 1 white ball. So in that case, we have not touched any red ball. We will still have 3 red balls out of 5. Then since this ball is white, so 1 white ball will be left to the second draw. So we have 1 on 5. And we have not touched any blue ball. So we'll still be having 1 blue ball on 5. Note that for this dichotomous, this trichotomous rather, the sum is always equal to 1 for all of these branches. Then if the first ball is blue, so we'll still have all the 3 red balls left. The second draw will still have 3 red balls which are left out of 5 in this case. The number of white balls will still be 2 out of 5, and there will be no blue ball for the second draw. So 0 on 5. So this is the tree diagram that illustrates this relationship. Now they say hence or otherwise. Hence or otherwise, hence means we can decide and use this tree diagram to continue with the remaining part of the solution. That is for D and E, or we may use a different method. So that's hence or otherwise. But if they just say hence, it means you must continue this solution. With this particular example, we are continuing with this solution. So the probability that a blue ball and a white ball are drawn, that is D. So to find the probability that a blue ball and a white ball, remember they have not given the order here if the first ball is white and the second is blue or whatever. They've just said a blue ball and a white ball. So the first ball can be blue and the second is white, or the first is white and the second is blue. That's what we have in mind. So for D, probability of blue and white ball means the first can be white, the second is blue, or the first is blue and the second is white. And remember that for us to have probabilities along these branches, it is multiplication and means multiplication. So the first is white and the second is blue. This is it, and so first is white, is 2 on 6. This is it, white, 2 on 6, and the second is blue times 1 on 5. So this is 2 on 6 and 1 on 5. Or is addition. Or the first is blue. If the first is blue, we have 1 on 6, and the second is white times 2 on 5. So when we simplify this, we are going to have 2 on 15. The E part of the equation says the second ball is red. So they're only interested here in the second ball being red. So if the second ball to be red, the first can be red and the second is red, or the first is white and the second is red, or the first is blue and the second is red. So these are the different possibilities. So they only talk about the second ball here. So the probability that the first is red and the second is red is 3 on 6 times 2 on 5 plus white red, 2 on 6 times 3 on 5, plus blue red 1 on 6 times 3 on 5. So simplifying this gives us a half. So the probability that the second ball is red is equal to a half. So this one is just the same as the probability that the ball is red. The ball is red because there are 3 red balls out of the 6 balls. This brings us to the end of question 2. You can see how simple and fast it is. What is the trick? The trick is solve more questions. Answer more questions. As you watch, make sure you solve each of the questions we have solved on this paper. You may watch and it will look very easy until you solve. If you don't solve, you don't gain the skills. The key is to solve. During the GCE, we are not interested in how much you know about probabilities. We're interested in how much you can write down on what you know. So this brings us to question 3. Welcome, guys, to question 3. If you have not subscribed to this channel, it is very, very important to subscribe now and click on the notifications bell so that whenever we upload a new video, you are immediately notified. Please, guys, like our videos, share our videos to all your Facebook and WhatsApp groups. That is the only way you are going to motivate us to make more videos for you out there. Please, if you have not shared any of our videos, today you should start sharing them. Share to all different groups in which you find yourself. There is a share button below this video. You are going to see it. It looks like an arrow. Click on it and you can share on all the WhatsApp groups in your phone and the different Facebook pages you have. So question 3 reads, the probability distribution of a discrete random variable x is given by, so the probability is given by these step functions, as you can call it. So we have probability of x equals x is equal to, so these are the different probabilities. And what are the values of x? You have x equals 1, x equals 2, x equals 3, x equals 4, x equals 5, x equals 6. But since the values are discrete, so you start x takes a whole number of values. And the probability for each, when x equals 1, what is the probability, is given by this function. Probability when x equals 2, and so on. So from this, they're asking us to find the value of the constant k. B, the mean of x and the variance. Sub 2, of the large number of candidates applying for a job in an enterprise, 5 are qualified. The candidates are interviewed one after the other until the first qualified applicant is interviewed. Find the mean number of applicants interviewed. And E, calculates to 4 decimal places the probabilities that the 5th candidate interviewed is the first qualified applicant. Let's dive into the solution to this problem. So the A part of this question wants us to calculate the value of k. And we know that for this discrete random variable, the sum of all of those probabilities should be equal to 1. Let's look at it again. The sum of all of those probabilities should be equal to 1. So if I look for the probability of when x equals 1, all of this, sum of all of these probabilities should give us 1. So we have k into 1 plus 1 when x equals 1, plus k into 2 plus 1 plus k into 3 plus 1 plus k into 4 minus 3, and so on. The sum of all of that should give us a value which is equal to 1. So for the first case, we are going to have k into 1 plus 1, which is 2k, plus k into 2 plus 1, which is 3k, plus k into 3 plus 1, which is 4k, plus, now from x equals 4, we are using the second part of the function. We're going to have k into 4 minus 1, which is k, plus k into 5 minus 3, which is 2k, plus k into 6 minus 3, which is 3k. So the sum of all of this should be equal to 1. So from here, we have 15k is to be equal to 1. And of course, k equals 1 on 15. B, to find the mean. To find the mean, I would like to make this to be this small table because students always get confused when we come to the mean and the standard deviation here. They always forget to substitute these values of k and the values of x in that function to find the probability. That's why I'm laying emphasis and I'm using this table. Okay, so here the probability when x equals 1, when x is equal to 1, we will have k into x plus 1. K into x plus 1. The x is 1, so 1 plus 1 is 2. 2 times k is 2 on 15. Okay, so that'll give us 2 on 15. And when x is 2, 2 plus 1 is 3. So 3 times k is 3 on 15. When x is 3, we have 3 plus 1, 4 times k. So 4 times 1 on 15 is 4 on 15. Now when x is equal to 4, we are using the other function. When x equals 4, we have 4 minus 3, which is 1. 1 times k is 1 on 15. Plus when x is equal to 5, 5 minus 3 is 2. 2 times 1 on 15 is 2 on 15. And of course, with this one, you have 3 on 15. So these are the probabilities which we are going to use. Now for the mean, we know that the mean is given by, for this type of probability distributions which are discrete, the mean is given by, that's x bar or mu, is given by xi times the probability of xi. So each score times is probability. So we have 1 times 2 on 15. This gives us 2 on 15. 2 times 3 on 15 is 6 on 15. 3 times 4 on 15 is 12 on 15. 4 times 1 on 15 is 4 on 15. 5 times 2 on 15 is 10 on 15. 3 times 6 on 15 is 18 on 15. So what is the sum of all of this? So the sum of this will give us, for x bar, we will have 2 on 15 plus all of that. When we sum all of that, we're going to have 52 on 15, which can be written as 3.46. Sum all of this, will have 52 on 15, can be written as 3.46. I like to use the table because it summarizes the work with this. And the next part of the question is to calculate, that is C, to calculate the variance. But the variance is given by each score minus the mean score squared times the probability of that score. So the deviation of score squared times the probability. So in this case, we're going to begin with when x equals 1. So 1 minus the mean, 1 minus 3.46 squared times the probability of 2 on 15. Okay, so this gives us 0.81. Then next score is 2 minus 3.46 squared times 3 on 15. That gives us 0.4302. Next one is 3 minus 3.46 squared times 4 on 15. We have 0.0581. The next score is 4 minus 3.46 squared times 1 on 15, which is the probability. We have 0.0189. Then we have 5 minus 3.46 all squared times 2 on 15. This is the value. The next one is 6 minus 3.46 squared times 1 on 15, times 3 on 15 rather. And this is the value. So when we sum all of this, it's going to give us the variance. And the value we have is 2.297. So this is the variance. Now, the sum 2 of the question reads, of a large number of candidates applying for a job in an enterprise, 5% are qualified. 5% of the candidates are qualified. The candidates are interviewed one after the other until the first qualified applicant is interviewed. Okay, find the mean number of applicants interviewed. Find the mean number of applicants interviewed. So with this type of questions, it is a geometric distribution. Why? They have given us the probability of success, and the interview is a continuous process, continuous interview until they find the first candidate that is qualified. So it describes the number of failures before a successful outcome. So suppose you are the recruiter and you need to find a suitable candidate to fill an IT job. This is an example. Unfortunately for you, great IT talents is hard to come by, and your chance that a suitable candidate will be interested is, let's say, 15%. So using the geometric distribution, you could calculate the probability of finding a suitable candidate after a certain number of failures. So here, the single parameter is the probability of success. So the probability of finding a successful candidate. So in this case, thus, the probability of success is P of X equals 1 minus P to the power X minus 1 times P. This for the geometric distribution, right? All right, so here the mean is given by 1 all over this probability of getting the first successful qualified applicant. And the variance is given by 1 minus P, all this on P squared. So these are the characteristics of the geometric distribution as already know. And so we move, so at D now, the mean will be equal to 1 over what? 5%. That gives us 20. Okay, so the probability of finding the first successful candidate or a qualified one. So the mean is 1 on 20. And from here, we can equally find to 4 decimal places, the probability that the 5th candidate interviewed is the first qualified applicant. So the probability of X equals 5 is the first successful one, should be 1 minus 0.05 to the power 5 minus 1 times 0.05. Simplifying this gives us 0.0407 to 4 decimal places. They knew why they asked to 4 decimal places because they knew that the probability is as low as it is. So guys, this brings us the end of question number 3. We will dive into question 4. And if you have not subscribed to this channel, please, you have to do that now. And the second thing after subscription, which is very important, is to click on the notifications bell. If you don't click on the notifications bell, you might not be notified when you upload other corrections. There are many corrections that are to be uploaded, but we actually need to know what students want and if they'll actually subscribe and are interested before we do the uploads. So uploads will follow your comments. Share our videos. When we see the number of shares, we are motivated. When we see the number of comments, we are equally motivated. So you have to motivate us to actually do the work for you. Thank you so much. And our thanks also goes to our foundation and all the hands there out there in Europe that are actually giving us a lot of technical support. This brings us to question 4. In a certain city, 1 car in 4 fails an inspection test. A sample of 10 cars is selected at random from the city. Calculate the 4 decimal places the probability that at most 2 of the 10 cars fail the inspection test. Sub 2, 3 is a computer student who is learning how to type. The number of errors she makes per page follows a Poisson distribution with mean 3. Calculate the 3 decimal places the probability that the first page she types will contain exactly 3 errors, and B, there are at least 3 errors on the first 3 pages that she types. So look at the question again. In a certain city, 1 car in 4 fails an inspection. So 1 in 4, let's take note, a sample of 10 cars. So we want to find correct to 4 decimal places the probability that at most, that is not more than 2, fail the inspection. So this follows a binomial. Why do we know it's a binomial? Because that gives us the probability of the first successfully selects a failed car. The probability to successfully select a failed car is 1 in 4. That's the probability of to successfully select a failed car. You have to take you have to actually take this into consideration. You have to take note of this statement. So that 1 in 4 is actually the probability to successfully select a failed car. That's how we do this here. And so this is the probability of successfully selecting a failed car. And they have given us a sample of how many cars in a sample of 10 cars. So this follows a binomial distribution with parameters NP. So we have 10, 0.25. That's our binomial, okay? 10, and 0.25. So the probability that we have at most 2 is going to be equal to the first is a failure, or the second is a failure, or the third is a failure. This is it. Okay, so this will just be equal to the probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2, which is equal to n combination 0 times 0.25 to the power 0 into 1 minus 0.25 to the power n minus 0, that's 10 minus 0. Then now for the second case, we have 10 combination 1 times 0.25 to the power 1 into 0.75 to the power 9 plus 10 combination 2 times 0.25 squared plus 0.75 to the power 8. Now that the sum of these powers like this must always be equal to 10. So we have 2 plus 8 is 10, 1 plus 9 is 10, 0 plus 10 is 10. So you can look at more on these binomials and so on other videos. So simplifying this will give us 0.0563 plus 0.1877 plus 0.2816, whose sum is 0.5256. So these are results, and so you should give an answer to 4 decimal places. So this is the probability that at most 2 cars of the 10 fail their inspection. Now the B part says, the sub 2 says, Siri is a computer student who is learning how to type. The number of errors she makes per page. So listen to this very well. The number of errors she makes per page is 3. So calculate to 3 decimal places the probability that the first page she types will contain exactly 3 errors. So the first thing here is to ask ourselves is, what about distribution is this? The question says it's a Poisson, and even if the question does not say it's a Poisson, we should know that it's a Poisson. Why? Because they have given just one parameter. And what have they given? They have given just the mean. So this is a Poisson. Okay. So find the probability that the first page she types contains exactly 3 errors. Note that for the normal distribution, the probability of x is equal to exactly a is always equal to 0, but the Poisson, the case is not the same. Like the previous question, the answer, one of the previous questions, you saw that I explained there that with that case, it's going to be 0, or maybe the question is coming after. With the Poisson, the case is not the same. So for this Poisson, probability of exactly x equals 3 errors will be 3 factorial 3 to the power 3, where this base 3 is our lambda, and x is the 3. All that on 3 factorial is the power minus 3. So this simplifying just gives us 0.0224. These are 3 decimal places. Now B, in the case of B now, we are being told that there are at least 3 errors on the first 3 pages she types. Now, with this first case, we're talking about 1 page. If we have only 1 page, she makes 3 errors. Now, if you have 3 pages, how many errors is she going to make? She's going to make a mean, an average of how many errors? So if there are 3 pages, she's going to go make an average of how many errors? Of 9 errors. So this now is a Poisson distribution with parameter 9. So there's an adjustment. And this is how the Poisson always behaves now. So now that we have the 3 pages, the mean number of errors in the 3 pages should be equal to 9. So the probability that she makes at least 3 errors means that she can make 3 errors, or 4 or 5 or 6 or 7 or 8, and so on. Okay. So this will just be equal to the probability of x equals 3 plus 4, x equals 4, x equals 5, and so on. So it can be as many as possible. But we cannot add this forever. So what do we do to simplify this? We are going to, first of all, look for the probability of x strictly less than 3. And 1 minus the probability of x strictly less than 3 is equal to the probability of x greater than or equal to 3. So this is the shortcut we are using. Okay. So we can replace all of this by 1 minus the probability of x less than or equal to 3. And the probability of x less than or equal to 3 is equal to the probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. So we have 1 minus probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. Okay, so we apply our Poisson here. So bringing in this formula, we are going to have 9 to the power 0 on 0 factorial e to the power minus 9 plus 9 to the power 1 on 1 factorial e to the power minus 9 plus 9 to the power 2 on 2 factorial e to the power minus 9. Simplifying this will give us 1 minus 0.006232, and that's going to be 0.994. That's the result that we have. This brings us to question 5. Guys, please, if you have not subscribed to our channel, make sure to click on the notifications bell, watch this video to the end, leave your comments, and share our videos to all the different groups in which you find yourselves studying. Thank you. The probability density function f of a random variable x is given by, so this is the probability density function is given by this. So a 12th into a 2x plus 1 for x ranging from 0 to 3 and zeros elsewhere. Calculate the mean of x, the variance of x, and the upper quartile of x, giving your answers in 3 decimal places. So let's calculate the mean. How do you calculate the mean of this probability density function? How do you get the mean? So the expectation or the mean is given by the integral from negative infinity to positive infinity of x times f of x dx. But here that's given us the limit to work from 0 to 3. So it is defined only from 0 to 3. We'll have the integral from 0 to 3, 1 over 12 into 2x plus 1 now times x. So that gives us 1 over 12x into 2x plus 1 dx. We can factor out this 1 over 12, which is a constant, and we'll have 1 over 12 into the integral from 0 to 3 of 2x squared plus x dx. So this integrating this will give us 2x cubed on 3 plus x squared on 2. And the integral, the limits of integration is from 0 to 3. Putting in these limits of integration, we'll have 18 plus 9 on 2 plus, that's minus 0 plus 0. So upper limit minus lower limit. And this will give us 1.875. So this is the mean or the expectation. So we have given our answer to 3 decimal places as the required. Now the variance. So var x, the variance var x or sigma squared is given by the integral from negative infinity to positive infinity of x minus mu squared of f of x dx. So this is going to be equal to 1 over 12 x minus mu, all of this squared, into f of x dx. F of x 1 over 12 into 2x plus 1. So I'm going to expand this and simplify. Expanding this and simplifying will give me 1 over 12 into x minus 15 on 8 squared into 2x plus 1 dx. All right, I think I've written now the same thing again. So this point will give us 1 over 12 into 2x cubed minus 13x squared on 2 plus 105x on 32 plus 225 on 64 dx. So integrating this will give us 1 over 12 into x to the power 4 on 2 minus 13x cubed on 6 plus 105x squared on 64 plus 225x on 64. The limit of integration is from 0 to 3. So when you put in these limits and simplify, we're going to have 1 over 12 into 117 on 16. So the answer is equal to 39 on 64. So this is our variance. So this is the variance. You can write the answer now to the number of decimal places by dividing. And lastly, they want us to calculate the upper quartile. So to find the upper quartile, we know that the formula for median, the median is given by the integral from negative infinity to the median is equal of f of x dx is equal to a half. That's going to be give us a half of the curve. Now, the upper quartile is the 75th percentile. This a half is the 50th percentile. So 75th percentile should be the negative infinity to the 75th percentile. That is the upper quartile of f of x dx should be equal to 3/4. So that's the idea. If you talk about the lower quartile, we are going to work with from the limit from the integral from negative infinity to lower quartile of f of x dx equals 1/4. So the upper quartile will be equal to Q3. So integral from 0 to Q3 of f of x dx should be equal to 3/4. So when we integrate this f of x dx, So the integral of 2x plus 1 dx should be equal to 3/4. This gives us 12 into x squared plus x. And then the integral, the integral boundaries should be from 0 to 3 to cure 3. So when we open this out and simplify, we will have cure squared plus cure minus 9 equals 0. This is a quadratic. So the discriminant is b squared minus 4ac, which is 37. And from here, our q3 will be equal to 2.541 to 3 decimal places. So these are upper quartile. You cannot calculate your answer for this, and your answer goes above 3. Why? Because this probability density function is defined from 0 to 3. So all the values that you have for mean, median, upper quartile, lower quartile, whatever, should be in that range. Yeah, should lie from 0 to 3. Anything outside that should mean that you have made an error somewhere. All right, this brings us to question number 6. Guys, don't forget to subscribe to our channel and to share our videos. When you subscribe on the notifications, there is still enough in stock for you. Leave your comments below on the papers you'd like us to upload and the corrections you'd like us to do. We are here at your service. And in return, what you have to do to motivate us is to share our videos, especially to your Facebook platforms, to all your study WhatsApp groups. You are helping other students actually focus on their exams, and at the same time, you're motivating us to carry out these videos. We enjoy doing this, but you should also motivate us for us to know that we have fans out there who are enjoying our work. Question 6, the wages of workers at the construction site are normally distributed with mean mu and variance sigma squared. A random sample of 36 workers is selected and their ages x summarized as follows. So the summation of x equals 630 and the summation of x squared equals 11,109. So using this sample, find the unbiased estimate of the mean mu and variance. B, the 97% confidence interval for the mean. It is known that the mean age of all the workers at the construction site is 18 years. Test at the 5% level of significance so that the mean age of the workers has changed. So this question equally involves hypothesis testing. Let's start with the first main part of it, which is the age of this number of workers is normally distributed. The first thing is normally distributed, and we have a random sample of 36. So this is sample is selected and summarized as follows. Summation of x is equals that, summation of x squared equals that. So the sample mean, on the other hand, is the sample mean is an unbiased estimator of the population mean mu. The sample variance is an unbiased estimator of the population variance. So here we have x bar to be equal to 1 over n. This for the sample, right? Summation from 1 equal to n of xi. So this gives us 630 on 36. So the estimated mean is 17.5. While for the sample, for the variance will be 1 over n minus 1. This is for the sample, right? 1 over n minus 1 summation x minus x bar squared. So we put in our values. This will give us 1 over n minus 1 summation x squared minus n x bar squared. So this is another formula. Either you use this first formula if you have the data, depending on how you have the data, or you use the second one. So you're going to use the second case because you have given the summation of x squared, and we have also look for x bar. So this will go to 1 over 36 minus 1 into 11,109 minus 36 into 17.5 squared. So this gives us 84 on 35, which is equal to 2.4, which is equal to 2.4. Now B, we have to find the 97 confidence interval for the mean. To find the 97% confidence interval for the mean, so the 97% confidence interval for the mean would be if mu plus the z statistics times sigma on root n. Now, why am I using the z statistic? Because now when you get to this point, this is the question you have to ask yourself to choose. Should I use the z statistic or the t statistic? So this is how we answer the question. What is the sample size? The sample size is 36, right? So when the sample size of 36, 36 is more than greater than 30. When the sample size is greater than 30, then we use the Z statistic. Otherwise, if it's less than 30, we see that it's a small population. Okay, so we are going to use the 2T statistic. So in this case, we use the Z statistic, and the Z score for the 97% confidence is 2.17. So putting this and simplifying an equation, these are the summary. So the Z score. So the 97, you have this in your formula booklets. So you have your formula, you check from your formula booklets and you see this inside. Since you have to use your formula booklets in the exam, you read the value from there, you apply it. So you have 17.5 plus or minus 0.868, okay? So you can further simplify this. I'm just ending at this level. So you have 17.5, you add this, that's the lower limit, and then that's 17.5 minus this, that's the lower limit. Of the upper limit, we have 17.5 plus this value. So see, let us test at the 5% level of significance whether the mean age of the workers has changed. So we have to test if the mean age of the workers has changed. From our calculation here, we saw that the mean age for this sample is 17.5, right? But now we are being told that it is known that the mean of all the workers that is 18 years, according to the equation. So the mean of all the workers is 18 years. That is actually what they found out. So the population mean is 18. Now the sample mean you calculated here is 17.5. I want us to check if the mean has changed. So our hypothesis, null hypothesis will be the mean age is 18. Then the alternative is the mean age is not up to 18, right? Yeah, because you are going to use this Z. If you use it is not equal to 18, then we might have to use something else to test, not this Z. Since you're working with Z, okay. Probability, probably if it was a T statistic, I'll take a mu is not equal to 18 for the alternative hypothesis, H1 or HA. So here we have n equals 36 and error alpha is 0.05 for the significance. So as Z, we have to look for the Z score, x bar minus mu on sigma root n. So what will this give us? So we have 17.5 minus 18 on 2.4 root 36. What does this give us? Minus 1.25. So the probability of Z less than 1.25 is equal to 0.106. Now, this value that we have, is it greater than 0.05? Because we are testing at the 0.05 level. So this value is greater than 0.05. So whenever the value is greater than 0.05, it means that there is an insignificant difference. Okay, so it means that we are going to reject the alternative and accept the null. So there is an insignificant difference. So we accept H0. There's an insignificant difference. So the mean has not changed. The mean is 18. Okay, guys, this brings us to the last question, maybe the second to the last, question 7. And question 7, we have the height of students in an institution are normally distributed with mean 156 centimeters and standard deviation 5 centimeters. Find the probability that a student selected at random has a far height between 154 and 163 centimeters. Sub 2, a packet contains a large number of seeds, 40% of which are advertised to give red flowers. 500 plants are produced out of the seeds from the packet. Find the mean and the variance of the number of plants having red flowers among the 500 produced. Using the normal distribution as an approximation to the binomial distribution, find the probability that of the 500 plants produced, more than 190 are red flowers, and exactly 220 have red flowers. So we're going to start the first part of the equation in which we have the height of students and institution is normally distributed, normally with mean 156 and standard deviation 5. To find the probability that a student selected at random has a height between 154 and 163 centimeters. So since a normal distribution, we have been given mu to be 156 and sigma to be 5, and it's normally distributed. So the probability of a student's height lying between 154 and 163 should be equal to, so we have to convert this to the z-score, right? Because the normal distribution. So to convert to the z-score, we are going to have 154 minus the mean on the standard deviation should be less than z, less than 163 now minus 156 on 5. So we are converting this to the standard z-scores. So this will be the probability of z greater than minus 0.4 and less than 1.4. And with this probability, since the z-score is the probability, the area under the curve, so this area will be equal to the area when z equals 1.4 minus the area when z equals negative 0.4. So this probability of z less than 1.4 minus probability of z less than 0.4. So reading the table, the values from the normal tables, you have 0.919 minus 0.345. So the probability will be equal to 0.574. Now, the sub-2 of the question states that a packet contains a large number of seeds, 40% of which are advertised to give red flowers. 500 plants are produced out of the seeds from the packet. So just from this statement, we can look at the type of distribution in which we find ourselves. So the success here is 0.4, and the number of elements is equal to 500. So this is binomial. They've given us the two parameters. So we should find the mean and variance of these 500 plants. So the mean for the binomial is given by NP. So we have 500 times 0.4, which is 200, and the variance is equal to NP into 1 minus P, which is 500 into 0.4 into 0.6, and that gives us 120. Now, for the B part of sub-2, using the normal distribution as an approximation of the binomial. So we are going to use this, we are going to use the normal distribution and approximate this binomial and find the probability. So let's start by approximating. So we start by looking at this statement. So let X be a random variable based on n trials. So n trials where P is the probability of success, such that we have mu is equal to NP. Right, this is for the binomial, and we have sigma is equal to the square root of NP into 1 minus NP, which is the standard deviation. Okay. Now we are going to check if this mu is greater than a certain value. So since our mu, which is equal to NP, is greater than 10, so whenever our mean is greater than 10, and the probability of an n into 1 minus P is also greater than 10, sometimes talk about greater than 5, but standard is greater than 10, then it means that this case, X has approximately a normal distribution. So X is approximately normally distributed. So it is normally distributed with parameters, which we are going to see. Parameters, this normal distribution, what do we have? All right, so we have a mu, which is equal to, with mean, equal to 200. And we have standard deviation squared, which is 120. This is the variance. So now from here, they want us to find the probability that more than 190 will have red flags. So probability of X greater than 90. So probability of X greater than 90 for the area under the curve is same like 1 minus the probability of X less than or equal to 90. So we convert this to the z-score. So we have 190 minus 200 on standard deviation. So that will give us a probability of 1 minus z less than less than minus 0.91. This will be, when you read this value, you have 0.181. So 1 minus 0.181 is equal to 0.819. So this is the probability of that. And the second part says that exactly 200 will have red flags. And this is the statement, exactly 200. The normal distribution, okay, I mentioned this before, I think 3 questions earlier. The normal distribution is a continuous distribution. And the probability is represented by the area under a curve. So it is a contribution, a continuous distribution, and not a discrete distribution. Okay, so in this, with this particular probability, x is not actually some sort of a discrete distribution, it's continuous. So thus the probability of x to be exactly equal to a given number, say x equals a, is always equal to 0, because you consider it's either less than a or greater than a, so it's equal to 0. Except otherwise, the equation focuses on something else. Normally, the answer here should be equal to 0. So except otherwise, the equation is referring to something else. And if it's referring to something else, then we may be talking about the probability of x less than or equal to 220, which will be equal to, convert this to the z-score, and that will give us 0.966. So to convert to the z-score, you just have 220 minus the mean. What's our mean here? 200, all that on root 120. You're going to have your z-score, p of z less than 1.83, and then read your value now from your normal tables. Guys, so please don't forget to subscribe and to leave your comments to these videos. And we are moving now to the last question. It's very important. You can equally join us on the WhatsApp groups for GCE preparation. Visit us at our blog at www.gcemathpanel.blogspot.com or gcemathpanel.com, where you can get past papers for other subjects, and some of our corrections are there in PDF. Equally, we are actually moving to a new site which is called the gcepreps.com or gcepreps.blogspot.com, where students can prepare for the GCE with notes, past corrections, lessons, quizzes, and a lot more. Please visit all of these blogs and you will find out that you have a lot in stock for you for free. If you're in need of an online tutor, you can contact us directly from blog. So last question, it is believed that there is a relationship between the ages and the monthly income of employees of a firm. The table below shows the ages X in years and the monthly income Y in tens of thousands of FCFE of 8 employees of the firm. So these are their ages and these are their monthly incomes in tens of thousands. So calculate this map is the product moment correlation coefficients of age and income, the equation of the least squares regression line of monthly income on age, and the minimum sum of squares of residuals, so the regression line on age. So we start with the product moment correlation coefficient. So let us note that, so this is a table I've written out back this way, and these are the ages. We have the sum of these ages. From here, our x bar will be 254 on age is 31.75. Then we have a y bar is equal to 202 on 8. But note this answer should be 10 to the power 4 because these values are in tens of thousands. These where students may end up making a mistake too. Then we had another column now for x minus x bar squared because we need that in the formula. So x minus x bar, we take each score here, each of these x 32 minus 31.75, and we square it. Since the frequency is 1, so it's just that square and so on for all of them. So when we sum at the end, we have 55.5. Then you do the same too for y, but note that when for y, when you square this 10,000 is as 10 to the power 4. 10 to the power 4 squared is 10 to the power 8. Okay, so we're going to have 27 minus 25.25 squared. The next one is 18 minus 25.25 squared. The next one is 28 minus 2.5 squared, and so on. You square all of them. When you add, you're going to have 135.5 at the end. Then we can now move to x minus x bar into y minus y bar. So this now, in this case, since y bar is 10 to the power 4, this value will be times 10 to the power 4. So when we do all of these computations, x minus x bar into y minus y bar of the first value, you have 32 minus 31.75 into 27 minus 25.25, all of that times 10 to the power 4 is the 10 to the power 4 here. The next case, you have 29 minus 31.75 into 18 minus 25.25. The next one, right down to 30 minus 31.75 into 27 minus 25.25. When we sum all of this, we are going to have 74.5. We can now apply this in our formula. Before applying it, we have the following variances. The variance of x, that is SX. The variance of x, SSX, is 55.5. The variance of y is SSY, which is 135.5. That's the variance. Then the formula is given for SXY. That's the variance. This variance x times variance of y. The deviation of x times deviation of y. The summation of all of that to give us 74.5 times 10 to the power 4. Applying this in the formula, you have a product moment correlation coefficient. The Pearson correlation coefficient is SXY on the root of SXX times SSY. So we just fit in these values. When you do like this in the tabular form like this, it is very, very neat, and you easily avoid errors, which you can now easily put in your formula like this, and you start the work is easy also, unlike writing thousands of pages. So the value of R gives us 0.8591 to 4 decimal places. The B part of the equation wants us to find the equation of the least squares regression line of monthly income on H. So they want us to find y on x. So that equation of the line is given by y equals a plus bx. And we start by looking for b. B is equal to the product moment correlation coefficient times the standard deviation of y. Okay? So that is the square root of this one. Because this is the variance, square root of this gives us the root of sy on the standard deviation of x, the root of ssx. So from there, b will be equal to 13,423.53. And we can now look for a. A is equal to the mean of y minus b times the mean of x. So the mean of y here, we have the mean of y to be 25.25 times 10 to the power 4. So that gives us 252,500 minus b times x. What's the value of b here? B is 13,423.53 times the mean of x is 31.75. So a value of a will be equal to minus 173,697.21. And therefore our equation becomes 173,697.21 plus 13,423.53 x. And therefore the equation of the regression RSS, the residual sum, also known as the minimum residual sum of squares, can be given by these calculations. Thank you guys so much, and don't forget to subscribe to our channel. We have so much for you. For those who are doing maths mechanics as well, we have a lot in stock for you. Don't forget to also watch June 2020 paper 3. Thank you so much. Don't forget to subscribe and click on the notifications. Bye-bye.